ahead and start streaming now. Okay, gentlemen, the floor is yours. Feel free to take questions or ask us to hold the questions to the end. Do you have a preference?
Question flies to the end.
Okay.
If you guys want to interject, it's fine. I do want to lead off by saying we are going presentation though, just because it's not looking too hot.
So if you go to your display settings.
Do what? I can leave like this if you guys don't mind.
Up to you. You can also switch if you want. Okay.
So we are Ajax. Before we begin, though, I just want to start off by saying thank you to the faculty and everyone that came to support us. It's been quite a fun semester, but it's also been quite easier than semesters we're used to. So last semester of the MISM is fun. So again, yeah, just thank you for everything you guys have done. We just wanted to give you guys one last hurrah before we probably don't see you guys that much going forward in the future. The problem Ajax wanted to tackle was that cybersecurity, learning it has been quite difficult for us. With Vance as our professor, he was amazing to learn from. But when it came to actual homework, we had to look it up online, and the videos that we found were quite terrible. The people that were teaching them generally fit the stereotype of introverted and have a hard time speaking to people, especially when it comes to explaining a topic that's hard to understand, like cybersecurity. So this is just an example of a video that will show you how hard it is to learn cybersecurity.
There's usually good music though, right?
There's usually good music. And they usually, because Kali Linux, they actually offer like a screen recording software in their operating system. But no one really owns a mic, no one wants to talk, so they actually just go into the terminal or open up LeafPad inside Kali and just start typing their instructions. And this is how you learn to do any ethical hacking whatsoever, just by kind of mimicking what they're doing. You have no idea what nmap-a means because he's not here to explain it to you. You just have this nice little beat in the background. So we did not like that, and we wanted to try and solve that problem. But we also wanted something that we can use going forward in the next couple of years. We wanted a portfolio that showed future employers or potential employers, A, we know how to program, and B, we know cybersecurity. And here's a website or something that we can refer you guys to in order to prove that.
And part of why that's important, like most STEM degrees, most companies care more about the projects you've done outside of class or care more about you being able to show that you know what you're doing rather than a certification or a degree. I've worked in cybersecurity for the past year, and that field is even more so. Even if you have a master's degree, unless you know what you're doing and can show them that, they don't really, your master's degree won't really mean anything. So that part of our portfolio was really important to us going forward. But to solve the problem of these awful tutorial videos, we wanted to make the tutorials that were succinct and just really easy to understand and follow, and appropriately use music, which for our scope usually meant no music. We distributed our videos via YouTube and then a website that Troy developed. So to tackle this capstone, we divided responsibilities between ourselves according to this slide. So I was responsible for those 3 tutorials listed there, and then any additional videos if I had time. And then Troy was primarily responsible for the website. With permission from Jeff Jenkins, he started last semester, but then we ran into some problems. And so we had to devote a lot more time to that website throughout the semester than we planned. And then he had the social networking, social engineering and network sniffing tutorials. And then he also did some additional videos that he'll cover.
So before we dive into like the demo of the website, I just want to go over some things that I delivered and things that I learned. As mentioned by Andrew, I did some packet sniffing that was done via Wireshark. We actually had a high-level overview from you, Dr. Missouri.
Ooh, years ago. Yes.
On the tool. And then reopening it and reteaching it to myself, I realized how confusing it was when we were learning it many years ago. The social engineering toolkit, which I actually think you demoed to us in the junior core as well. I got to dive into that and learn a little bit of credential harvesting and show my actual employer what the social engineering toolkit is capable of doing, and they just became terrified of how easy it was to form a website like on the fly. The introduction video, this is what I did in Jeff Jenkins' class, just an understanding of what Ajax is and what we're trying to tackle. Installing Kali for those who don't know how to do it, if they're brand new to a virtual machine. Wi-Fi, doing penetration testing on either your Wi-Fi or hopefully only your Wi-Fi, not your neighbors. Proxy chains and Tor, becoming anonymous online. This is something a lot of people are actually looking into right now. And then gaming consoles, this is what I've been working on the last about month or so. The keywords that people are looking up with the word hack inside it on Google is generally how to hack an Xbox or how to hack a 3DS or a Wii. And so I started tackling that to get more traffic onto the website. And then this is a little bit of our tech stack that I used in order to solve that. So Nginx and Apache, you'll notice there's actually two different versions of everything I used. And that's because early on we ran into some problems like Andrew mentioned. And that was getting SSL working on our website. No one wanted to go to a cybersecurity website that didn't have HTTPS on the link. It just screams sketchy. So we couldn't get that working for the longest time. I tried getting a free certification through Let's Encrypt. That wasn't working. So I immediately just blamed them as the source and went to GoDaddy and paid $50 to get their certification. That didn't work either, which sucked. So I had to end up going from Apache on an EC2 instance to DigitalOcean using Nginx. And I went from CentOS, which is a Red Hat enterprise version, to Ubuntu, which is Debian's CentOS, which is a Red Hat enterprise. And that actually started working surprisingly, but I found out down the road the real reason why the SSL wasn't working was just the name servers in GoDaddy's website. You have to actually email them to get it changed and permanently be changed. Otherwise, it just switches back after half an hour. It's not planned, that's what kept happening. So I finally got them to lock down the name server 1, name server 2 to go to DigitalOcean, and then my SSL just started working. Then here's the technologies that I used, and I'll show you guys them on the website. So currently right now, if you come to Ajax, you're actually just presented by the countdown timer. It's actually a month after the presentation because I wanted to go over any input you guys had and get it fixed. And then before alpha comes out right now, it's just beta. And I say that in all my videos. If you guys see the countdown timer, there might be bugs going forward. We just do that so we can actually have a little bit of testers coming into the website and telling me what bugs there are. And if that countdown timer is there, they know, hey, it's not a complete product right now until that countdown timer is gone. So you can bypass that just by coming to our login page or our welcome page, and then you're greeted by our layout, which I actually designed in your class, Professor Anderson. So hopefully it fits all the UI, UX rules that we discussed. But you'll notice we'll have a couple things, just history of Ajax and pricing plan. We'll talk about that later, what we do. This is the IS599R class I took from Jeff Jenkins. This is where that video came from. And you'll be able to go to our tutorials to see a couple things that I have done. You'll be able to sort through Red Hat or Blue Hat or Kali 101 or Security Plus topics, or you can just view all to see what kind of portfolio we have currently on the website. So here's my Wireshark video. Here's social engineering, how to install Kali. You can click on any of these, and you come to here where you can actually play a video on the left and scroll right here on the right to have detailed instructions.
One of the problems, one of the reasons we did this write-up tutorial is sites like Khan Academy have a transcript that you can follow along with the video. So because people learn in a lot of different ways, so you're able to learn audio-visually, and then you're also able to learn textually. And then if you have accessibility issues, this tutorial write-up offers them a different way of being able to learn this material.
Another problem we ran into pretty early on is something that we were discussing, I'd say around March, is on Facebook. If you have a video playing and you start scrolling, it'll actually minimize to the top left corner. You can continue scrolling to the instructions. We tried to get that working, but we decided just to let that go for now, since we wanted to focus more on content for the sake of this deliverable, rather than something kind of cool like the video minimizing to the top left. Those are a few of my videos. I don't have time to show you a couple hours of videos that are currently on YouTube. If you guys want, you can go check them all out right here. And then Andrew can talk about what he delivered.
Cool. So so the 3 tutorials that I focused on were Hashcat, which is a password cracking tool, Nmap, which is network mapping and port scanning, and then penetration testing. So each of these are a series of anywhere from 2 to 6 videos. These were a few of the tools that we worked on in Tony's class, and that I myself had a particularly hard time learning and mastering. So I figured this is a really great opportunity to finally really learn how to use these tools, as well as teach other people about them. And then the other thing with a few of the videos is they each have a file download, so the users can follow along as they go through the tutorial. That's another problem with some of these online tutorials is they just, like with Nmap, they're just going to scan their own network, or they're going to password crack some random file that you don't have access to. So this allows people, again, a third way of learning, which is by actually going in and doing it themselves. The purpose of these was just to give them, just get them on their feet, teach them the basics, and then let them go on and learn from there. So the things that I learned from this, obviously learned some new tools. In terms of Nmap, I made a mistake of, I decided to make some materials for the students and learn some things myself, and I ended up scanning my whole local network, and that took 5 days. I thought it would take like 6 hours. So something I learned is it's really important in a scan to just scan like one target and see how long that takes, and also make sure that you're getting the information that you want. So that was a big lesson I learned. With penetration testing, there's a pen testing life cycle, which I have a video on, and I found that works really, really, really well. Troy's mom, the company she works for, gave us permission to do a pen test of their company. And so I was able to learn a lot of hands-on experience from that, doing an actual pen test rather than just a theoretical one, that then really applied into the videos I made. Something I learned, though, was that it's important to not have your IP address blocked, which happened to me. I still can't access the company's website. So Troy reminded me I should have used proxy chains, then he made a video on how to do that. Make yourself anonymous. So if you're pen testing, don't use your home IP address. So yeah, so I'll go ahead and demo some of the videos that I did. I'm actually really, really excited about these. So we'll start off here with Nmap. So again, you've got the basic structure. Here's the video. Here's the tutorial description. Up here, you can download the files. So this first one, because this was a really long topic, what I did with the first one was just give a conceptual overview of Nmap. So we talk about kind of like what is it, how do you get it installed, we talk about some of the command structures and what they mean. And then we come down here and in a walkthrough tutorial, I go through and show the user, the learner, how to use it and put it into practice. So here on the side, it's everything that I'm saying. It has all the different scans that I've done. And then if you download the files, you'll be able to actually look at the output, which I've anonymized. And so then the person can take their time instead of spending 5 days scanning their local network, they can just go in and view the file themselves. Are there any questions on Nmap before I move on from there? Okay. So the next one is Hashcat, which I'm super excited about. I took, Troy and I took the forensics class a year ago, and part of that is password cracking, but it's with the FTK GUI. Now FTK is awesome, but it does cost about $5,000 a year. So for most people, it's not usable. But Hashcat is free. It's in the command line. And I took a lot of my information from this tool on this tutorial from a book, which I reference in the slides. And again, we just kind of talk about, give the user an overview of what Hashcat is. Then we talk about the password cracking methodology, which is about 9 steps. Basically, it's get the hash, the password hash from the file or device that you're trying to encrypt. See how strong the hash is. See how fast your device, your machine can crack. And then from there, go ahead and try cracking it. The second video just goes over how do you install just the material that you need. There are a few things that we use. And then in part 3, So we go through and we do a couple of tutorials. One of them is on, I don't think this is going up all the way. It looks clear at home, but so we have a PDF file that I made. Password's just 123 for simplicity. They're able to download that file and then crack it. So we provide a password list. It's actually about 270 megabytes. So then they can use that going forward to other users. And then the other one that we do is a list of MD5 hashes, and they're able to come through and crack this, and here the output's right here. So they have the hash on the left, colon, and then the password on the right. So really the idea here was to be able to show them a few ways that you can use hashcat, help them understand what do the commands mean, what is the command structure, because when I used it, I tried, I Googled, spent hours, it made absolutely no sense to me. And so the hope is that people viewing this will actually be able to learn from it. And I took, when I made the tutorials, at Risk Recon, which is a security company, one of my tasks was creating internal training videos for them. Made about 11 videos, and so I took skills that I learned from that, as well as teaching IS 110 last summer, and the feedback I got from there, and really tried to incorporate those principles in my videos. Just the last two things. So this is pen testing. Talk about the pen testing life cycle here. There's then one here on Metasploitable, which is an intentionally insecure Linux distro. So we talk about how you install it, as well as VirtualBox, and then we go through kind of the principles we talked about in other videos, so port scanning, except this time in an actual pen testing environment. We talk a little bit about Metasploit, as well as Armitage, which are two different hacking tools. I did get a comment on this one, and the person had a typo. I thought it was Armitage, not Armitage, but they said it was really helpful. So, and then the last video that I made was how to compile and run a C program in the command line. When we did advances at Tony's class about a year and a half ago, we did a pen testing tournament class, and some people that were in the IT penetration testing class had a leg up, in part because they were able to find exploits on the internet, and they knew how to compile those and use them. Whereas when I found those exploits, I wasn't sure how you do that. So that was another key part. Are there any questions about any of the videos I've made? Or
Can we see a little sample of kind of the quality?
Sure. Yeah.
You showed us what was. I want to see the
Let's
the after picture.
let's come here. Let's do hashtags. Welcome to this, the third and final video of password crafting and hashtags presented by Ajax. Now that we've covered some concepts and installed the required tools and software, let's start crafting passwords. We'll do this by going through a step-by-step walkthrough on how to use hashtags. So what we'll be doing is we'll craft.
Will you jump to the middle of the video now?
And then we'll show the result, and then we want to output it to this text file. So go ahead and click enter, and it should be pretty quick since this is a pretty easy password. And then if you come here and you open your .txt, like we talked about earlier, we have first we have the password that's encoded, and then the colon, and then the password is right there. So in this case, it's 123.
Perfect. Thanks.
Yeah. This PDF file. Well, anything else? Any other questions?
If anyone wants to just check out these videos later on, just do objects.com and just do the /tutorials. That'll get you directly to this page. It's live right now, so you can actually check out all the content we currently have.
Are you going to talk about your pricing model? Is that
Yeah,
upcoming?
that's future plans for objects. So I actually want to continue working with this as a project going forward. I noticed you guys asked that in a couple of the online streams this morning, so I just decided to add it to the slide deck. So currently, the estimated net worth of objects on just GoDaddy is over $1,000 for the domain. We got an offer for someone to buy it for like $950 something at the beginning of the semester, and ended up just not even responding to that person. Wanted to hold on to it. We were told not to, but I did anyway.
Yes, you were. Solo, you can.
It's still growing in estimated value, and the reason
good.
why that is because we need a lot more traffic on the website and a lot more awareness around the domain. Also because it's a short 5-letter domain, which is kind of rare to get. And how Ajax came to be is I was just trying to find a domain. I typed in Ajax, the HTTP client you can use for plugin. I typed in H on accident and I was doing it really quickly, and it just said there's domains available. And I thought, hey, I'll just take it. So there really is no real good story behind how that domain came to be.
But it's Ajax, right? Not Ajax? Ajax?
Yeah.
Okay.
There really is no way to pronounce it per se. It's kind of hard for people.
That's the wrong answer.
No,
it's Ajax.
So I actually want to turn all the tutorial videos into employee trainings down the road. And I actually already started beginning a programming script using a tool called Skipfish in Kali Linux. I want the client to come in, submit their URL, have Skipfish go through, do a web crawler on their entire website and report scan and spit it out to them as a test of what we can do for them. And I want to implement a login and thread implementation on the website similar to Stack Overflow. Stack Overflow is meant for programmers, but right now there really is no good source to go to for hackers on getting advice or just seeing a forum on current topics. OWASP is close, but they don't do it that well either. And then we want to continue making videos going forward, kind of improve our content, begin promoting the actual website after the countdown timer is done and beta is finished, and hopefully turn Ajax into a secondary company. And this is kind of some analytics so far. Here is my YouTube channel. I started this quite a while ago, and those views collectively is the entire channel. And just hypothetically, our base plan right now on Ajax is $40, $39.99, and it tells you what we offer. You can go all the way up to Smart, which is $100. So we want to try and actually promote this and start implementing Swipe, I think is what it's called, that we use in the Albert's class to get payment. And so hypothetically, if only 100 people out of these million that view the channel were to purchase the basic plan, which is $40 a month, times 12 months, that's easily not a great salary, but a livable salary, at least here in Utah. I don't know what that would be post company costs for the server and whatnot, but that is future plans for Ajax. We want to try and actually make it into a company down the road. However, right now it's more of an online portfolio to point future employers to. And at this point, 4 minutes to go. We would like to answer any questions if you guys have.
What questions do you have? Are you familiar with MITRE's CVE and CWE? Okay, so that's something that you definitely should kind of read up on. Probably provide a little video overview of, kind of a repository of common vulnerabilities. CVE stands for Common Vulnerability Enumeration. And then the CWE is weaknesses, and the weaknesses is focused on software development. CVE, though, is kind of the de facto repository for 0 days and other things to kind of have them start, tagging. Really great resources. There's a couple other sites there as well that would be nice resources on your site. One other suggestion there is, you might look at how you can, piggyback on security.stackoverflow.com. So Stack Overflow has a lot of different kind of branches for different topics, and you can kind of spin that up. So you might be able to contribute, get some recognition there of folks that are really into this, and pull them back to your site as well, and or integrate that as some way into your website.
With the security Stack Overflow, we go there on my work at least, and it's more development security. Yeah,
it's a mix.
Implementing OAuth 2 within your login credentials. But when it comes to penetration testing, that's where we want to try and differentiate ourselves.
Yeah, so the model for Stack Overflow is actually really great that way. You can kind of start up a whole new, area. It's community-wide, so you couldn't necessarily control it, right? But it might provide that resource without you having to go through and develop everything on the backside. Great. Other comments or questions? All right. Thanks, gentlemen. Let's see. Next up, we have Emily and Allie with their UI UX design thinking course.
I saw your snap.
I woke up and I was like, Snap's not going to make a return from the road. Is your guys' site live?
Yeah. Beta.
Oh, beta. I was trying to find it earlier also.
Mine's kind of slow first.
Yes, that's exactly what we're doing.
It's unusual.
Is that flattering or threatening?
Yeah, it's actually
It's got
my parents' house. Because I heard one of them. The one I heard.
It is unusual.
Was not a redesign.
Yeah.
Supplements like that. Should have insisted that it be my house.
Yeah.
Fix my house.
Well, and or taking advantage of some of the materials that you can pull in.
So they actually taught us first block this semester.
We've got about 3 more minutes. We'll hold just a little bit tight here.
For people who are, planning on watching.
That's right. Oh, maybe my clock's out. Oh.
It's fine.
Let's see.
Right now, it just sends you what's in the systems. So it's still Cerebral.
They're in Wisconsin. They do healthcare software.
So I think that along the lines, it's
Kind of a hodgepodge.
shops are actually.
Rotate development, a bit like type stuff.
Cool thing that's really
And Alan, we admired your work this morning. Memory Hub. I don't know if you were here for that. That would be nice.
Almost there.
Oh yeah, Professor Surgery.
Yes, sir.
We forgot to mention, if you want to buy an Objects t-shirt, we're also on Amazon.
Nice. I was a little disappointed that you didn't sell, but you're right. It looks like according to that metric, $100 since I encourage you to sell. So
Did you reach back out to them?
No, I just never
he
responded.
just discounted my idea right away. Do you mind maybe moving to the back table there? Would that be okay? Okay, that would be great. That way, kind of those watching the presentations are a little bit closer.
Yeah, it's fine.
Thank you. If you're not going to be watching the presentation. Okay. All right. Next up, we have Allie and Emily with their design thinking course that they taught during the first block. A lot of upfront work went into this one. A lot of work all around. Go ahead. The floor is yours.
So I'm Emily and this is Allie. And we taught a UI and design thinking class in the first block. And so, step right into it. So we realized that IS program has a problem that we never talk about, or we rarely talk about UI. We talk a lot about UX. We talk a lot about how to build applications, and a lot of our students are doing contract work, and so having a foundation in UI is important because sometimes that's an all-in-one way to design my website and build it, or way to design my app and build it. And so we talked to the students and we got a list of topics to cover. We covered everything from design tools like Sketch, talked about color theory, alignment tracing, we did mock-ups, we did typography, buttons and links. Other topics that we covered were brand management and vision, vectors, which led into logo design, and then design thinking as a whole. These topics all came from a survey that we sent out to IS students, both in the master's program and the bachelor's program, just to kind of see where their skills were lacking and see what they would want to course on. And so that's what structured our class. And so our class structure every day was, we said a prayer, we had a spiritual thought, and then we had a design thought. The design thought was the students went out and found a website or resources and critiqued it in class just to get them into the design, the UI thinking. And that took 15 or 20 minutes every day. And then after that, we either have a lecture day or a lab day. We decided to alternate because we teach a topic and then we wanted the students to apply it and have something tangible that they walked away with. And so that allowed for us to go around and help the students. It allowed for them to really learn the tools that they were using and to walk away with something that they could then be proud of. And then every week we had a design write-up, which was just a design thought actually written up. And then we had a mini project. These mini projects corresponded with the topic that we taught about. So say we were talking about typography, they would decide on typography for a website that they were building. Or say we were doing color theory that week, they choose brand colors for whatever project they chose to work on. Our last day of class is February 27th, and it was a bittersweet day. Many of the students asked, hey, can't this be a two-day class? But we chose to go an alternate direction and take this course and repackage it and put it on Udemy and Skillshare. And so we ended it after the first block.
So after our class ended on the 27th, then we sent out a survey to all of our students so that we could get feedback on what we could do better for the second half of our capstone, which was packaging all of our class material into an online course. So this is some of the feedback that we received. A lot of students really enjoyed learning Sketch, so those industry design tools. They really liked getting to an in-depth knowledge about that. So we took that in consideration with our course. Students also really enjoyed being able to holistically create this style guide, so understand how to monitor a brand and make it consistent throughout whatever design materials we make for a company. So a website and print materials and apps, whatever it may be, being able to create a consistent style guide. They enjoyed that. They also really appreciated personalized feedback on their designs. So being able to see how their specific designs they come up with, how did they personally improve as they move forward. They really enjoyed that. Some of the criticisms we got is that our design thoughts that we had at the first did not contribute as much as we hoped. We did those design thoughts so that they would get into the mindset of looking for styles or themes that they liked so that they could apply it to their own designs. But most students said that it didn't actually help that much with their personal improvement. Also, because it was such a front-loaded workload, trying to figure out the entire class structure and assignments and everything right at the first, Emily and I didn't have time to create as meaningful as assignments as we hoped. So a lot of students said they wish that there had been both more assignments, that we hadn't just focused on the style guide, and that the assignments had been more meaningful, so more scenarios that they'd actually come across in the real world. So we also took that a lot into consideration with our Udemy course as well. So we ended up creating assignments, specific assignments, more meaningful assignments per topic that we covered. So same thing, we said that we spent too long with style guides, so we ended up doing that for a couple of weeks in a row. When we taught color theory, we just had them add on to the same style guide. So we changed that. Also, students remarked that they wanted more time actually following along rather than just being lectured at. They wanted real experience where they're doing something and improving their skills personally. So to remedy that in our online course, we created follow-alongs after every single lesson. So 20-minute demonstrations where they could watch me do the assignments that we've just given them, so they could get an idea of what we want them to do. So after we created the survey and got feedback, and we actually started creating our online class. So we went ahead and we restructured all of our class content based on that feedback, and we scripted it all out. We added those tutorials and follow-alongs, and then we actually recorded them. And then we're currently in the process right now of still adding some material that we wanted to add and editing them so it looks good, and creating our Udemy and Skillshare courses. Those are the two platforms that we landed on. It's Udemy and Skillshare. And also, last slide, we want to distribute coupon codes to the IS department so that they can use this for students that are interested in improving their visual design skills. And in particular, we mentioned with Bonnie, our mentor, that we want this to be somewhere near her class, her user experience class, so that students can have that knowledge as they go into her user experience design class when they're creating their first prototypes.
And they can use that then to build off of their capstone,
So this is just a quick demo of what one of our videos look like. We're just going to show you the first 20-ish seconds. Here it is. What that looks like.
Color theory is fundamental to good UI. I'm going to walk you through the meanings of a lot of colors, and most of them you probably caught the meanings of subliminally, but I'm going to explicitly tell you
the computer, not the video.
Red is meant to be eye catcher, color meant to cause alarm. Think of warning signs. They're red. Think of that button that stops you from deleting something that you shouldn't. Also probably red.
So just quick demo, but videos look like
Nice.
that. And so our lessons learned from this is that creating class is a serious time commitment when you have to create all the material and all the assignments and everything, grading. Like, we have a lot more respect for our professors after
That's the whole
class.
reason we approved the capstone.
Yeah, it takes a lot of effort to create a meaningful course. So we found that. We were surprised to find from the survey that students actually wanted more assignments. Like, we thought that we were going to be giving them the best class ever with like really light workload and everything, but they said they wanted more and more meaningful assignments.
There were students who spent like 3 to 4 hours every week doing the projects for a 1.5 hour course. And they were like,
Also, and this is kind of intuitive, but it was driven home by this class. Lectures are good. Actually following along is better. Actually doing something yourself is how you learn it best. So it's important. Also, recording is really hard when you actually are recording your face, and it made me feel like this and this and this all the time. It's so hard. So I'm going to do it over and over and over again to get the right shot. So.
Love your background though.
Oh, thanks. Yeah, that's my room. Yeah. So, any questions?
Is the coupon code still available for your Udemy course?
Yeah, any course isn't up yet?
Okay.
yeah, we're planning on sending it out to all current students of our class as well, and how many years you want to take it, or any alumni who would be interested in taking it.
So how would said alumni find out about the coupon code? Okay, you'll post something on Island? Nice.
Yeah, that's the one I have.
What are you doing as far as your setup for your recording of your videos and the mic for your audios?
So we actually borrowed Troy's mic,
Uh-huh.
and I have a DSLR camera
Yeah.
that I've been using, and I just rented a tripod from the library.
Rented or just checked out?
Rented.
I think you can check
I mean,
out.
checked it out.
Oh, okay.
It's free.
Okay. I was
That's what
like,
we were getting at. Were you paying?
yeah, it's like don't pay for it.
Yeah, it's free.
Yeah. My experience has been online courses. You think video quality is super important, which it is, but really it's the audio quality that trumps everything. Content, other things. If you have great audio quality, that's what differentiates. Any sense of, kind of interest in the broader market in the course? That if you're not up yet, you probably don't have a great sense for that yet. But
Not sure.
I think it'll do well.
I've talked to people, I've talked to the girl site, because that's neat, we do that in the world, and so there's a need for it, but
Yeah.
we haven't really done much research.
Yeah, I think it'll sell.
Well, maybe that's your next step, is back to Pluralsight once this is all done.
Hopefully. I got this one.
So you guys taught like UI and design. What were the highest impact topics? Like, which topics were people like just making the most difference in my ability to design or think of design?
Most people, like, what they said was just being able to use the tools, period. As far as design theory, I think that alignment and spacing, honestly, just like being able to create a good layout is what affected most people. Like, that's where I saw, like, in grading assignments, that's where I saw the most improvement.
Something that we did that was kind of interesting was we let the students iterate on it. So if they turned in an assignment, they could resubmit that assignment for a better grade. Because we believe that like as you like go through the design review process, you're going to get better feedback and create better designs. And so that's where we saw the most improvement. I think people really liked all of them. One of our favorite lectures was the logo day. People really liked that lecture.
Awesome. Well, thank you. Great job. Nice impact for our students with that project. Okay, it looks like we've got a little bit of time before our next one.
Well, we had questions.
So we'll go and mute live.
your dad's filming.
Oh, is he?
I thought so.
No, Little's Law.
Okay, we're live with audio now too, so guard your conversations.
Maybe Ruby.
Well, I mean, internship. Job, I guess.
Oh, get that.
Congrats. I won't be doing the Rails at Microsoft. Good fun.
Okay, take it away anytime. 20 minutes for the presentation, 5 minutes for questions. Do you care if we ask questions during, or should we hold them until the end? Okay, perfect. The floor is yours.
All right. Hello, everyone. Welcome. This is our capstone presentation, which is entitled Trash Talk. So my name's Alexandra. I don't have pink hair anymore. This is Spencer, and this is Lucas. And we're all second-year master's students graduating in a couple of weeks.
And Matt Little's here too. He's the
Matt's also
he's
here.
the brainchild, the founder,
President, CEO.
CEO. We didn't put him on the slide though because he didn't have the slide.
All right, so our agenda for today, first we'll start out with some background on the project, how it started, where it came from, and then our approach to solve the problems that we were faced with. And then we'll have a quick demonstration of our web application that we built. And then at the end we'll talk about our lessons learned.
So going into the background of the problem, when the creation of Trash Talk, Matt was trying to solve a problem, is that, you know, if you pass through the dumpsters, you can see how inefficiently they are collected, how the trash over there, like dumpsters like these, that, you know, they're just full, overflowing, and they can stay there for many hours or even like days even. So the purpose of Trash Talk is to solve that problem of inefficient collecting. And the second problem that's also solving is that whenever there's a pickup, the routing that the trucks make to collect this trash is also pretty inefficient. So Trash Talk has the mission to solve these issues, to collect them in a timely manner, and also to use routes that make it more efficient the way that we collect it. And the way that we achieve that is by installing sensors. So there are sensors in each of the dumpsters. Some dumpsters may have even 2 sensors, and they will report and then they will measure how much the fullness with the equation that we have measures the fullness of each of the dumpsters, and then it sends it over by satellite to us. And we use an API in order to receive this data. So we're gonna jump in a little bit and talk about the tech stack and how we use it to solve this problem using the sensors.
So we had like a few main things that we needed to accomplish. We needed to create a database that could store this data and it would be easily accessible. So we decided to use MySQL because it's free, and we know it, and Lucas is a wizard. And then we needed a web portal to access the data for people to be able to look at the data, and users that previously hadn't had access to it, basically to democratize access to this data. And then once we did that, we needed to provide a way to create routes based off the sensor data. So we're getting reports, we have data, now we need to say, okay, let's put this all together in a way that the end user can gain some value out of this. And then this is a little document of kind of how the data flows through our application. We have sensors the particle sensors, they send data to the particle API. Once it hits the particle API, it triggers a webhook that posts to our Rails API. We do some transformation so that it can be consumed a little easier, and then we serve it to the end user. And then end users can use that to make informed decisions, they can use it to make routes, basically just make their life easier and save themselves a lot of money.
Awesome. So I'm going to talk a little bit about the costs we have. So the sensors are $80 up front, and they have a 3 to 4 year battery life before the battery needs to be replaced. and then we pay 80 cents a month per sensor for that cellular data that Lucas was talking about. And then Heroku hosting for our web application is less than $50 per month. And as Spencer said, MySQL is free, so our database hosting is free. So our costs are pretty low. And then our expected revenues, so we're charging up front $100 per sensor, and then $5 per month per sensor for the reporting. And our goal is to capture about 10% of the waste consulting market, which is actually a $1 billion market right now. So it's getting real.
We're going to go ahead and jump into the demonstration a little bit of the website. So we have, even though we're in the final stages of development, since we delivered this last Saturday, this iteration. So since this is we're just going to show that the developer environment. But if you go to trashtalksensors.com, it's the deployed web version where you can see a lot of the things that you see right here. So this is just a landing page. We wanted to make a simple yet informative page where a user could jump into the website and see what Trash Talk is all about. So very simple, straightforward landing page, contact page, so we can also see what we do and about a little bit more about the content details. So one thing that you may notice here is that we have just these options. We have a contact, a sign-in, and a sign-up. So if a user comes and tries to sign up, and I just put my email, carvalho.lucasp, I will not be able to sign up because users have to be pre-approved on the website. So they have to be on the list that is determined by the admin. So there are 3 roles in the website. There's an admin role, which controls everything on the website. There's a VIP role, which is the admin of a company. And there's a user role, which are all the users. So in order to you have to be a VIP in order to approve those signups. So I'm going to go ahead and sign in. So I'm going to sign in with one of our clients, momentum.com. And we're signing. So as you may have noticed now, we have this dashboard option and account option as well. So enabling employees to sign up, which Spencer will talk a little bit about later, but then dashboard. So in our deployed version, this reflects live data. Since this is development, this shows only some prior data that we have from our development stage. But we just wanted to make it clear and easy for the user to see that you have 6 dumpsters that are between 90 and 100% full. That means that they need to be picked up, and 1 dumpster that is less than 50% full. And over here, and Spencer will talk a little bit about the route creation, but over here you can also see all your sensors, all the containers, that means the dumpsters. So the dumpsters, so there are sensors in containers. And over here you can also see the map of all the containers for different companies. So we just use the Google API, just plug in, so so the admin can have an idea of how spread out your containers are. So going back.
So let's just log in. Let's just say we are acting as the Momentum admin. He sees, oh, I got a bunch of containers that are full. Let's get those picked up. Let's call this the Salt Lake route. We will add these to the route, submit the route, and then we can go check if the route was created. It was. The distance between the points is 22 miles. We want to view the route details. It'll show us the order that we should go visit these routes at, and then we can click and it'll take us to which location we want to go to.
Does the Google API produce the route optimization for you, or are you using something else?
We got an algorithm from Google. It's called OR Tools, Optimization Routing Tools, and it provides a traveling salesman algorithm for us, and that's what we use. So we altered that algorithm and especially for
using Google's street data, or using just latitude and longitude
No.
or something?
Well, that Ore tools uses latitude and longitude.
Yeah, sorry.
Okay.
So in the future, we may look towards using the street
Yeah.
data, but for now, we didn't have time to implement that.
Yeah.
As well.
Fair enough.
Hopefully traffic
Okay.
and all that stuff in the future as well.
Yeah, so we have basically the shortest distance between, and then you can route yourself through Google based off.
Yeah. Got it.
Yeah, so that's that. And then if I were to say, oh, I've got Joe in the company and Joe needs access to this, I could enable Joe to sign up by adding Joe. Like I said, Joe at momentum.com. Would add in. And then Joe's there, and when Joe goes to sign up, the website knows Joe's approved, and Joe gets access. So yeah, that's basically the gist of it. We'll go back over to our lessons learned.
Okay, so there were a lot of hurdles. I'm going to start first by talking about the design. So we were basically starting branding from the ground up, which was a really fun challenge for me. Figuring out how we wanted a website to look. And we really wanted it to have a clean feeling, even though we are talking about trash. So that was an interesting challenge too. Initially, our user requirements, we thought we were going more toward a visualization tool, seeing an overview of which trash cans are full and maybe trends over time. So we were looking at first into using Tableau or Power BI. And then we found that route optimization was actually the user's #1 goal, was our biggest goal. So it was a big pivot in our direction when we initially thought we were going to be doing a lot more designing, a lot more visualization, and instead we needed a lot more Google APIs and linking with maps and that sort of thing, and trying to make all of that look nice. So it's been an interesting challenge.
Yeah, and also with, since I'm going to talk a bit about this business intelligence side and also the route optimization. So when we started, like Alexander said, we thought that Tableau was going to be it, but $42 a month per company is definitely not something that we need right now. So we talked to Matt, and we just decided to make the visualization simple yet informative, so the user could quickly see it. And but some other challenges that we have is that we first had to deploy it to Heroku. Since we were using a Cloud9 environment, to use with Heroku, it was challenging because Cloud9 doesn't let you have to pretty much install the Heroku CLI in Cloud9, and it was very challenging. We could spend a lot of time with this. Once we had that, we also had to learn how to run Python in Heroku. So even though it's a Unix-based environment, it doesn't have Ruby or Python pre-installed. So the first thing, of course, was to install the Ruby environment, but then the Python environment wasn't working. So we had to go out and search on GitHub, fork the repository, change the code to reflect the ORTools version that we were using, and then use the build package, the custom build pack for trash talk. So that was another big challenge that we had to overcome.
As far as integration, there's a lot of data to integrate. We have the sensors sending data to Particle, and we have to get data from Particle to our database. And then we have to make sure that our database also works with the production database, and that, like Lucas said, we can run Rails and Ruby and Python all in the same instance. We took a little bit of time working on getting the Particle API and building our own API that would work with that. That was a big challenge that we faced, and we learned a lot from that. We also had to integrate a lot of stuff that we had never used before. So it was just a good learning experience all around, I think. We learned a lot about the technology stack. We all learned a lot about design and trying to make things look nice, and we're still learning a lot. So yeah, that's kind of our lessons learned.
Hopefully this will be a product that Matt could user for, I don't know, the next couple of years. That's kind of the goal, that this is kind of like building the foundation of a project that will grow and it will expand, it will be valuable to the company.
Any questions? Or that's it. You can clap.
Oh, I'll clap for you. I have a few questions. What happens if your website is down when Particle receives some, some data? Does that data just go off in the ether?
Yeah, that's so far it's something that we were on the verge of creating like a development version that is deployed on the web. That's going to be kind of like the redundancy of this. So like if a hook comes in, we don't need the data.
Yeah.
So that's kind of like one of our next steps to have like a development deployed version.
Yeah.
Will it only send one signal to the garbage can is full, or will it, if you lose that data, will you get another signal later?
Yeah, the signal I'm sure is redundant. I mean,
Yeah.
it'll call again, right?
Yeah, it's not like
Calls every
huge
5 minutes or
loss
something.
because
Hours?
It's like once an hour, once a day.
once every hour, once every couple hours. So it's not a
Yeah.
huge loss if that does happen. So
Yeah, I think that's it might not be worth building out, for that reason.
Yeah.
Once it's done, it's gone. I mean, historical information is interesting, but it's really the here and now where you're adding the value. Talk to me about your database. MySQL is deployed on your same Heroku instance. Is that right?
Yeah.
And do you currently have kind of a backup solution in place for that data? Kind of customers and other things. Have you thought down that road
we
yet?
don't have a database backup set up.
Okay. Yeah, it might be something to consider
Yeah.
strongly when you go forward.
Probably a good idea.
How many of these do you have out running right now?
How many sensors?
Yeah.
How many sensors?
There were like 80, but now it's like 30 or less. But there'll be more in the
Where
near
did they
future.
go?
I took them down.
Oh, okay. I'd like to think away.
Colin?
Well, there were a few that got destroyed, like 3 or 4 of them.
From the garbage dumping?
Yeah. The sensor, do you ever run into a problem where when you're dealing with garbage, something gets on the sensor and keeps it from registering correctly?
Or blocking the distance?
Blocking has been an issue, so that's why 2 sensors in a container is one of the better ways to do it. But yeah, so far we haven't seen a problem with getting stuck on it yet.
So talk to me about scalability. What happens if there are tens of thousands of sensors or thousands of users hitting the site? How does it scale?
So Heroku has really nice scalability options. It's literally a drag and drop that lets you decide how much computing power you want. So that cost estimate we gave, the $50 per month, that's actually an inflated cost estimate where we're using like 2 professional grade, they're called dynos. Right now we're using a free grade dyno and it works pretty good. So I think the scaling won't be such an issue from an infrastructure standpoint, but from like a usability standpoint, that would be where it's a little harder. And so one thing that going forward we're going to do is make it a little bit easier to implement company controls. Like say if Matt gets on or we get on, we see every company and every sensor for the company. That becomes a little bit hard to handle. So we're going to implement some controls where you can filter through companies what you want to see. And we'll probably also have to introduce some pagination stuff where you will limit data to what users can see. They don't really need to see 1,000 rows.
Right. Have you done any measuring of the throughput that you can get on the current site?
Well,
Yeah, we haven't. Well,
It's been fine in your testing, is your experience.
The thing is, since we have now 30 sensors, the initial idea was to create 2 separate databases, for example. A MySQL database, which would be your transactional, and then you send it to like a Microsoft SQL Server or something, which will be kind of your data warehouse, which you would store historical data. But since we realized, oh, it's not a lot of data yet, we didn't do it. But from as soon as we get, like, I don't know, maybe a couple hundred sensors, then hopefully we're able to scale out like this.
Who did the graphics design? It looks clean. and you were basically going from the ground up, right? Just totally from scratch. Did you do a responsive web design, or is this okay? So on a mobile
It's
device,
pretty mobile responsive.
Okay.
There are a couple things that still need to be tinkered with, but yeah, the graphics are scalable to the best size.
did you think about doing a? Oh, there we go. Yeah. Did you think about showing the dashboard immediately when they log in?
That could be, yeah, we could do that. That would be probably best.
Yeah, I think the principle is, you know, so right on. Don't make the user do more to get to the place where it adds the most value, or the default, you know, path.
Yeah, that's a good idea.
I'm sorry if you covered this earlier as I came in late, but so I've done home remodels and stuff like that. Sometimes there's hundreds of pounds of concrete, or there's heavy things in the trash can. How do you keep the sensors from getting knocked off?
That's more Matt's area he's working on.
Yeah. Thick steel brackets is the way to protect it. So, but yeah, that's definitely an issue that we're working on the engineering side of.
So I have a question. It's actually for Matt. What else is needed for an MVP to really take advantage of this for your clients?
I think MVP, like this hits it. Like this works. I think like the next step would be like doing some things with, well, making it more scalable, you know, making some tweaks there, but also like adding in historical data and analysis of that data so that you can also do predictive analytics combined with the live data, so that, you know, even better decisions can be made. But I think as far as MVP, like they've hit it.
Where was the biggest piece of work in the project?
Maybe the API,
getting connected with the API was just we didn't know the data very well, we didn't know the requirements very
Which
well.
API?
Particle API.
Particles.
When we received trash data, when we received the sensors data, I think since we were at the very beginning of the project, we needed like a post URL to be posted, so it was kind of challenging at the very beginning.
design stuff is also really expensive.
I have a question. So like the API part connecting with Particle is hard. Let's say it switches to a new one, so the data is formatted slightly differently. Is that still going to be like one of the most challenging parts, or
I don't think so. I think with the
you figured out how to do it?
So I'm curious, want to probe just a little there. So when we had talked earlier in the semester, I got the impression it was the kind of the uniqueness of how Particles API was connecting in, and so it was kind of technology specific. Is that accurate, or was it more just kind of having the hooks on your side that then you could connect to the API?
I don't think it was a huge particle problem. I think it was more like we needed to figure out the particle side, and then we need to figure out our side, and then we need to figure out how to set the data in the right way. So it was just like a whole process.
Okay.
But now that we have that process down, I think it would be easy if we had a different provider's API, whatever.
Have you talked to clients about this? Like, are people interested in using it?
Yeah, that's more Matt, but these are real clients.
They already are using it? Because we have some.
But Matt's also, and we'll probably help you out with some of this.
Are people really interested in it?
Yeah, so I mean, it's interesting. There are certain haulers that are not interested because they like picking up empty dumpsters and charging for that.
Oh yeah,
and so
for sure.
Then it's the end customer, which is the new customer. So like the church, for example, I've been talking with them. They're getting new contracts for their waste accounts coming up, and so using this to help save the church money, that's like they're interested in that.
That's very interesting.
Yeah, cutting out the middleman, and
making us.
Yeah, inserting yourself as the middleman.
Fair enough.
Saying, hey, we'll keep you honest. And, yeah.
Is there any competition already out there, or that you guys see, or is this just kind of like a new area for this like monitoring?
Yeah, this could take off.
We have a couple of competitors, but I think it would kind of depend, like Matt said, if we're going to aim it more at waste collection companies or people who need their waste collected. And that could kind of be our niche to find our own space in the market there.
We can work both ends.
Yeah.
Light up now before it gets full.
Yeah, that's true, huh?
Any more questions?
All right, thank you so much. Thank you.
We'll expect a minute.
Good job, guys.
Good. So we just need to add SSL certificate to the website, and then we can
All right, next up, oh, it's Grant.
unencrypted. Okay, sorry, sure.
Oh, he's right there.
Are you presenting?
Yeah.
Okay, I'm gonna come in. I gotta talk to you. Cool.
Good job. Good job, Alexandra.
Thank you.
Thanks so much for coming and supporting.
Thank you.
It's underneath, kind of up the top. Thank you. Appreciate it. We got another, let's hold for maybe 3 or 4 minutes, just so that we can get in sync for anyone that's jumping online.
Yeah,
I just
do this one.
Okay, perfect. Thanks.
I'm going to fill my pins though.
Perfect.
I came in just before 1 o'clock and they were already going.
But they kind of get a little anxious as they're sitting in the waiting, so sorry to.
Oh, there's one. You probably saw those at the corner of the camera on YouTube or something down there.
Who's the next team?
This is Grant Dexter, machine learning for Cursive OCR.
Okay, there we go. Yeah.
I saw it. I helped it. Kind of figure out times and sorry for the conflict. Yeah, certainly. I mean, I certainly expect that there would be a formal debrief for you if you're not.
We've already talked.
Yeah.
It's a friend who's coming today, so I probably can get away with letting Wednesday. Maybe I'll tell him I have a conflict.
You're kind. I can, make it known to the students too that you're so that.
I think I better stick around for it. So.
On our early discussions, it seems like it's an interesting fun.
Yeah. I'm happy.
Yeah.
That's what I was thinking.
Thanks so much for coming.
Yeah,
Kind of fun to always get back to campus, huh? Yeah. Super good. Grant, I think we're at time. Anytime you're ready.
Alright. Not very far away from here, up in the Little Cottonwood Canyon, the church, the LDS Church owns a vault which holds over 3.5 billion images. The majority of these contain cursive writing, the genealogy records that have been imaged and are being stored there and are in the process of being indexed. Millions more records with similar cursive writing on them are stored in state and national historical archives throughout the U.S. and other countries. So today I'll be talking about the research I was able to do this capstone project to use technology to speed up that process of digitizing cursive writing on images, and I'm pretty excited about it. So let's go a little more in depth into the background for this case, what it can be used, and then spend the majority of the time on the research I was able to do in the solution. So this is the thesis statement of this project. Computers can viably digitize 75% of cursive writing from historical documents. If it's any less than that, it's probably not a solution we want to use because we'll have to do so much manual work in it anyway. And if it's more than that, great, but I wanted to prove that we can at least get to 75% accuracy. There are a lot of OCR systems out here, so I'm going to just kind of explain how current OCR works for regular print writing, and then go a little more into maybe the challenges that are associated with cursive writing. So here we have the word Judas. An image has been taken of this print writing, all caps. It's a little pixelated, it shrunk down the size of the image, but essentially it gets passed into an OCR system which detects the location of each individual letter, segments it out, and then this is through the Google Vision API, and you can see it correctly gets the word Judas from this writing. So there are two main issues we come across with cursive writing, especially on historical documents. The first one is that there's a lot more noise. This is actually a fairly clean sample from a census where the background's a little noisy, there's a little bit of lines going through it, sometimes you'll have smudges on the page. And then the other thing is that the cursive writing all runs together, so there's no way to just segment an individual piece. So here, the same kind of segmentation is applied to detect edges, and you can't really tell. There's like 50 plus boxes on here, some of them are big, some of them are small. And when passed into the Google Vision API, we get gibberish out with 5213S4. So
pretty close.
Yeah, almost, right? So we needed to find a way to tackle those two problems, handling the noise in the image and the variance between documents, as well as the way that cursive writing works together. This comes in handy for obviously genealogy work. The LDS Church has indexed via crowdsourcing over 1 billion of these records, 1.2 billion. That vault, as I mentioned earlier, has 3.5 billion images, so there's a lot of work still to go. And if we could have a 75% solution going through and giving us at least a first pass at these records, it would significantly increase the speed of this process, getting all these records available online for usage. Some other use cases, I've been able to go out to the Church History Library in Salt Lake and talk with some of the people on the James Smith Papers project. And they have various teams of people going through manually transcribing what's written on these old documents from the era of Joseph Smith and early church history, and they still have thousands and thousands of these pages to go. So it goes through a process of one team writes down the original transcript, the next team goes through and validates to ensure that that content was accurate, and the third team goes through and does the final validation before it goes to print and a digital version gets published. And then finally, there are many historical societies which contain old notes and letters and documents that may have been imaged but not necessarily digitized yet for the writing. I've chosen to focus on these older documents, although there are other use cases like signing a check or other cursive notes that you may come across that are less common, so this was the area of interest for me on this research. So the first approach I took was to follow a similar pattern from standard OCR. So this is a page from the Book of the Law of the Lord. It was a journal where they recorded different tithing entries and various happenings in the area. So in order to send an individual letter, it was asked to classify it. With cursive writing, it tends to be written about 35 millimeter, and so I needed to find a way to rotate all of this text in an automated way to get my letter to like either like this, use Python, it's been code, it's been open source library, you can see so with this approach, you put the information, you rotate the whole thing based on an average angle of the writing on the image, and then it would go through the variables of text and attempt to classify the connections between text. So that way it can split it up in a standard OCR format, and then classify individual letters after that point. This approach I wasn't able to succeed with. It turned out that the connections between letters were just too difficult to classify and divide where the letter stopped and started. And so I had to move on from this approach. I think maybe with a larger data set, potentially could have worked out, but wasn't able to get this first approach to work.
So didn't you have some initial successes with it?
I did. If you can get to this point where they're segmented, I could get 90+% accurate classifying what letter it is, but getting to the point of segmenting them accurately was not optimal.
Okay.
So I could get to maybe 60% accuracy on segmenting the writing, but then 90% off of 60%. So it's a solution that's not going to work for us. So the next approach I took was rather than losing out on anywhere we might have writing that wasn't detected, I decided to still do the same rotation, but put a grid across the entire image, and then slide that grid in about 30% increments, so I would get multiple views at every portion of the overall image. So this is one piece of the grid. You can see it's rotated up at an angle, so we have fairly straight writing. And then the idea here was that we would just classify the letter that's in the middle. This actually made it a lot easier for me when labeling the data set, because I had to manually go through and say which letter is which. And it was so hard when it was just a single letter, but when I could see what was before and after, it made it a lot quicker for me. So I figured if I provided that same kind of context for the computer, the algorithm would better be able to classify. This approach, I think, also could have worked. What I discovered later is that you need about 5,000 as a base images per class that you're trying to come across. And because we have a possibility of 26 letters on each side of this letter with upper, lower, lowercase, or over 50 different classes that could be included with our one class. And so the size of the data set was just too big for what I had time to label and work through myself. So I also had to scratch this method. However, I also think this could have been successful in a larger data set. So then the third approach, I decided rather than doing the rotation and risk getting any of that off, I would just pass in even more context to the model. So in this case, we have the word is written out, and this is called multi-label classification. So instead of just saying this is or is not a certain thing, which is binary classification, or this is either an A or a B or a C, it could be an A and a B and a C, all in the same image. So this multi-label approach, turns out I needed over 1 trillion images passing into the model for this to succeed. It took me a few weeks to realize that that was my problem. I kept converging on a solution that would just guess the most common research, I discovered that it was because I needed a lot more images for this to work. So I had to simplify my approach. I only had about 2.5 weeks to go up to this point until I had to present something and come up with a solution from this last solution. So I decided to simplify and go back to one letter at a time. But this time, rather than caring about segmenting where the letter is, I would just pass this same grid over in smaller increments, and so that I get 3 or 4 views of the same letter, and I just classify each time what I think is the highest probability. So in this case, I think with this exact image, sometimes it didn't get the A. So it's the word David. It's part of this text right here, received with David former. It wouldn't always get the A in this one. It would be a little confused, and I think it's a different letter. But then by the time I got to this one, and this one, it was guessing an A almost every time. And so then by aggregating those results, I can apply a weight to that section of the grid to say it's most likely this letter, and then output my prediction for that segment. And this turned out to work pretty well, and I only needed about 5,000 examples per class. So I was able to get up to that within the 2.5 weeks for my data set, whereas with the other ones, there's no way I was going to show you.
So how long does it take to label 5,000 images? You automated the segment, yeah. You automated the segmentation of it, right?
So it takes me about an hour to do 300, which is.
And you did 5,000 per class?
So instead of manually doing 5,000, I found a way to augment the data set.
Oh yeah, yeah.
So an image like this, I would pass it into an augmenter. It's an open source QKS using TensorFlow backend. And it takes that input image and applies a series of randomized transformations. So it might rotate a little bit, it might skew it, it might change the colors. Yeah. But it does enough so that it's a different image, but still represents that A that I had originally passed in. So after doing a few hundred of these, I could then augment my data set to get to 5,000 with new images, but similar enough that the model can still learn from. And this approach, after I built the model, primarily using the Jimmy Smith papers images, I was then able to pass in some images from a census record, which was very different as far as the noise in the image and the writing and the time period. And it still was over 70% accuracy on that classification from a totally different data set. So it's a great way to validate that this was working. So just kind of an overview of how the pieces fit together. First off, we have this kind of adaptive text recognition, which can tell how big the windows need to be or how big the grid size needs to be. It slides over our original image. The data set, as I mentioned, so over these last few weeks, I was only able to get enough data to classify vowels, which is it's an imperfect solution. It's not all the way there yet, but it was enough. I felt that I could prove, hey, this works. So there's 5 classes currently. It goes through, and the way that we get rid of the extra noise, so when the grid's sliding across, and it happened to be just like on an offline, or there's no text there, there's 2 main ways to handle it. You can either pass it through the original area detection, like a regular OCR algorithm would do, or you can have another binary model that just sits at that intermediary bubble and says, this is a letter, or this is not. It just contains writing or it doesn't. So then once we get through that point, it passes into the model. The way that this model is set up is it's a convolutional neural network. It applies 2 layers of filters. The first layer has 32 different filters and then 64 filters on the second layer. So about over 1,800 filters are being applied. And those filters are just a pattern of pixels that it's looking for. So that pattern might be more common among a certain letter than it would be under another. There's one max pooling layer that just increases the processing time really. And then you have 3 dense layers within the model that are also known as fully connected layers. So it's just applying random weights to those patterns that it found and testing how effective those weights are at predicting that the output class is one of the letters. In the future, once I have the full alphabet classified within this model, it would make sense to add what's called an LSTM layer, a long short-term memory, which is then able to pass in the context of what was previously classified and what's classified next, and that way you get this additional context that provided to the model that can increase accuracy even further. So output on the vowels, I was able to get 87% accuracy, and this is only a one-dimensional model. So I took out the original colors that were coming in because of the limited processing power I had, and it took about 3 hours to train a model that was working sufficiently that I could then save and store those weights. So now in order to pass in new images, it takes maybe a couple seconds to load up that model and then classify the image and tell me what the most likely letters are within that image. So based on this research, I feel like computers can viably digitize 75% of the cursive writing on historical documents. I'm really excited about it. There's still plenty of work to go, but I think from the things I've discovered, I feel very confident that this solution will work going forward, and I hope we're able to adopt it in the industry and in the church as well for genealogy work.
Nice.
So letters that are written in cursive typically follow a language, and so they're not going to be uniformly likely. Are you doing? You mentioned in that last slide some predictive analysis too, but you talked about the number of combinations. It's probably not 52 on the right, 52 on the left that are likely.
You're right.
And so it's a much smaller set. Have you calculated what it really might be for, say, English?
I have not in that case, because I chose to move on from that approach.
You might still be using that though as you do your analysis. I mean, maybe as another layer of processing after getting some output from the OCR layer.
Yeah.
Okay. How much time does it take to run the algorithms you're using?
To train it?
To run it. So you've got a document you want to OCR. How long does that take?
Well, because I'm not classifying every letter at the moment, all I can test is individual letters.
I see.
And that's a fraction of a second to classify. So to go through hundreds of these letters on every page, I don't know, probably take a couple minutes.
But maybe you haven't done a complexity analysis on the algorithm or anything like that yet. Okay. That'd be interesting to see. What is the performance like in the long run?
I would say faster than the human.
Depends on which one it is.
So you use Python to write all the programs to do all of your training models.
Yes.
So where did you learn everything you needed to know to make this work? What did you learn here in classes at BYU? What did you learn on the job? What did you go and figure out on your own? I'm impressed. Like, I know we cover neural networks, but I don't know. Maybe Doug got into the details of a convoluted neural network versus a DNN or something else. I don't know. Maybe you did. But where did you learn all this stuff?
So I think Doug's class kind of sparked the fire for me. I took it during the junior core and really enjoyed it. At the same time, the startup I've been working at was wanting to use some predictive analytics and modeling, and so I got kind of a basis there with just NOR and very simple classification. So a lot of, as far as the convolutional neural networks, that was all kind of research done during the semester. I was really interested last semester in video and image processing. So I did a 693R class that let me kind of research that area further, and that's where I came up with this idea that we wanted to start using it for writing.
That's a perfect application. I would love to see some way to apply this, combining your job in a 693R with a special interest in other classes you take. I mean, I think it's a great model for students in MISM.
Are you aware of the work that Bill Barrett's group has been doing with cursive OCR?
No, I'm not.
Okay. He's over in CS, or I think he's retired or retiring. But anyway, he's done a lot of the image processing stuff in computer science, and I know they are interested in this area too. And so I'm curious as to how this fits with what they've been doing.
Yeah, I'd love to see that.
Are you interested enough to keep on working on this after MISM Capstone?
I am.
But
yes, I am interested. Because of time constraints, I know there's a lot of work left to be done on this, and so I guess that's like the biggest factor.
And Little's law is that you're never done programming.
Right.
So.
Well, from my perspective, very impressive, and I know the amount of in-depth research you had to do as you made progress throughout the semester. Really, really commendable.
How many hours do you have in the project?
Probably 170, 180 right now.
All right, thank you so much. All right, up next in 10 minutes, we have Hyperlights. Thanks, Ryan. Good job.
Can I get that name from you again from the CS?
Bill Barrett.
Bill Barrett.
Thank you.
I don't know how long they've been doing the cursive OCR stuff. Other OCRs. It's more the classic OCR techniques that I've seen most of them, but I have not read their stuff, stuff like that. But I mean, that's clearly the hardest piece of OCR. Yeah, to segment individual others,
Thanks, Mark.
Yeah. I'll be back a little later.
Perfect. Thank you.
yeah, or just Google around and see.
All right, thanks, John. Yep. All right, gentlemen, you're on anytime you'd like.
We'll show what one of our visions was at one point.
This is our house, our house. This is our house, our house. This is a monument to basketball. The foundation of tradition and walls raised by legends. This is a house that mountains. A house of Joe Barry and the Big Dog. Of the three amigos and the baby boys. This is home to 22 Big Ten championships. Beneath this dome dwells the most passionate, the most loyal, and the most fiercely family in the land. This is where we work hard and fight.
So yeah, so that's one of the light shows on the market, but our vision was to create something like this, where we would be able to coordinate phones to create images and patterns in a stadium. So we want to go for like light wave or something like that. And so, but we gained a lot of our inspiration from that other type of light show. So kind of briefly look at this, our tech stack. It's really flexible, yeah, because we spent a lot of time more on the mobile side, and so our back end is still evolving. So right now we're mainly using Heroku with Python and Django for the back end. So start off with kind of the challenges that we've learned, and as we go through those, we'll show the demos as we overcame those challenges.
So our initial goal was to eliminate the need for any kind of data communication in the stadium, because maybe in the future everyone will have a great Wi-Fi connection, or cell companies will have enough towers that it won't be a problem, but right now it's pretty common that you don't have a lot of service on your phone. So we did ultrasonic frequencies, which worked great for the exclusive iOS side of things. That was really good because iOS across devices, their internal clocks are very, very close to each other. Android, it's a different story. You can have a pretty big range on each Android device's internal clock relative to each other and relative to iOS. And so we did start using a little bit of NTP server calls, which is still a pretty simple call. It's very small, so hopefully even in a stadium setting, it's still possible. But that allowed us to, we used Apple's NTP server for the Android devices, so we got them on the same internal clock as iOS devices. And that kind of set us up to do some really interesting thinking. We didn't think it'd be that hard to synchronize devices, to get them really at the exact same moment in time. Some trial and error, and we came up with some cool math.
Yeah, so we have both of us have iPhones, and we also have an Android device. So we want to demo the syncing between the devices. So Android devices can be different. The timing can be different to 2 to 3 seconds. We saw. So I mean, if you're just sending text, you wouldn't even notice. Or if you're looking at your friend's phone, it's always going to be the same time. But when you're coordinating lights, is really noticeable. And so to sync the phones required a lot of research for us, and it's probably one of the main accomplishments that we came away from our capstone being able to do. And it's kind of like the baseline of where we want to go in the future. So we'll do that demo. So we're going to use the ultrasonic pitch from one phone to activate the other phones, and then we'll show the lights up here so then it's not in your face. So as you can see, they were pretty much perfectly synced, and that would be the goal in the stadium, would be all the devices to be synced by ultrasonic sound, and not only to do the same patterns, but to be choreographed. And so that was the next kind of big challenge that we took on, was how would we choreograph the lights in the stadium. So we kind of started looking at stadium seat map selections for if you buy tickets. So if you go onto a event site and buy tickets, that it's a nice little interactive map where you can choose where you want to sit. And so that's kind of where we started. And so there's basically like an SVG image of the stadium, which is like text that can be converted into a graphic. And there's a really cool library in JavaScript called Raphael that allows you to parse that text and make that interactive map. And so this class here is like pixel, but it represents a seat. So a seat has venue, a row, seat, and section. And then it also has the Raphael configuration, which is basically mapping the seat to the image of the stadium. So to give you an example of what that looks like, we have our show designer. So this represents like a 9x9 grid of rows and seats. And so each of these boxes is drawn by the Raphael configuration. So to kind of show you how we could change that is if we take this circle here, and we're going to edit the database because that's as far as we got in our development. And put that in there. And refresh. And now we see here, this row's seat now is a circle. So basically this grid is very fluid, and the SVG of an actual stadium would draw this grid. And so that was another one of the unique accomplishments that we were able to do in our capstone, is not only map the SVG to make the graphic, but also to the underlying database. And so we can save the state of each of the elements in the grid, and as we go to the next frame, you can see it would change, and we can also save whether we want the light to be on or off. So anything more to add?
Just that this was another challenge, thinking from the user's perspective. Somebody that maybe isn't super technical but still wants to design a show, trying to figure out what's the best way to present all this information to them. We talked about presenting them. This right now is like a single moment in time, like a single second in time. Each frame is a second. And we're thinking about how we can present to them 30 seconds at a time or 10 seconds at a time, and help them kind of see maybe how this would coordinate with the song. Most of the live shows have a song that goes along with them. And so this was where we were building towards when we were making this, thinking, the end users are not in the stadium. You don't want to make them do 1 million clicks. You also don't want to make them have to spend an hour designing a minute-long show.
Yeah, and another thing to think about is that a stadium has like 20,000 seats or so, and so that would be 20,000 entries in the database, and then for each second, each of those entries may have a different configuration, and so we had a lot of talk about how we would have that scale, and one of the solutions we came up with would be that the phone, when it asks for the specific configuration for its row, seat, and section, it would be hitting a like a database lookup that would only have the specific configuration for that, and like after the person was done creating the show, we would like process and load into that database. So, and that's something that we are working on currently in our next steps. Yeah, so some of our current challenges and next steps. I'll just start with the first one. We weren't able to get the demo into the iOS App Store, and I think one of the challenges, they kind of viewed our project as like another one of those light show app projects, and didn't see the full capability of what it could be.
Or even less than that, flashlight.
Yeah, like
I don't know what Apple's exact practice is, but it sounds like they're trying to crack down even more on duplicates and things in the App Store. They looked at the features of the phone we used and the different communications our app made, and all on this whatever readout it is, all they saw was flashlight. And the people we were talking to weren't developers and didn't understand the scope of it, how it's coordinated, each device is an endpoint in a greater system. They basically just told us, add more features and you'll get in probably, but it was really hard to communicate with them because they just didn't have the perspective. So we tried a few different times cleaning it up, making it look nicer. And we brainstormed a bunch of features we might add in, and in the end we decided it's probably better if we've talked a little bit about going into a BYU event, and we've talked to some people that are involved with it, and we think if we can say, this is an app from a credible organization, I think it'd go for the App Store a lot easier than this is a student project.
Right. For the next challenge, I mean, we were unable to create the UI for Android mainly because we were so focused on like creating a presentable app for the App Store. For iOS, which was really rigorous, and so next we need to kind of build our UI for Android, and then also the designer is really rudimentary still. I think what you saw in the demo there, the functionality is there, but the aesthetics and the ability to use it, the visual appeal is not yet there. So some of the things that we're doing now, at the mobile app contest, we actually met somebody that works with the Marriott Center Light Crew, and so he was interested in working with us to do this for the next year. So hopefully we'll be able to use that connection to create something that would actually be a viable product for them in one of their events.
And then Android UI isn't too hard. It's basically replicating our iOS UI and maybe updating both of them. They're both really simple. We try to keep it as simple as possible for now. Yeah, it's mostly functional. It looks clean, but it's not super well designed yet. But, and yeah, just keep working on the designer and try to figure out how we can make it really seamless, really easy for somebody at university to upload an SVG of their Stadium and just have the back end do everything for them from there, and they can just click and drag the patterns and lights that they want on them.
So is there any questions or that project so far?
Let's give you a hand first. I have a lot of questions for you. So, how do you send out the ultrasonic signal in a stadium?
So
Do you use the speaker system?
Yeah, so we use a speaker system, and we were able to test it in the classroom using classroom speaker system, and it worked.
Okay.
Like, even better than it does from the phones.
Okay.
So
If you could control the point sources of the sound signals, could you map out the stadium automatically? Because I'm assuming you have to have the user say, "This is the seat that I'm in."
right, and that's
they're
what
going to
we're
make
doing
mistakes. You know they're going to make mistakes. So,
Yeah. So we brainstormed a couple ideas. Like for now, we were willing to accept that they would make mistakes. Another thought we had was to actually integrate this like with their ticket system. So you know, their seating is from their ticket, whether it's like take a picture of their ticket or is like part of the ticket system.
But that won't guarantee they're sitting in their seat.
That's also another good point. As far as like beaming out the ultrasonic sound, we didn't really experiment with, you know, if we could pinpoint ultrasonic waves to a certain area and just like move it around the stadium, because we just weren't sure if that would be viable to create like, you know, BYU on the grid of the people in the stadium. So
yeah.
So you might be able to do something with the cell phone providers if you could get their buy-in, or, you know, I mean, have to teach people how to switch on the Wi-Fi, but set up special access points around the stadium, and then measure the relative strength to each of those, and then triangulate kind of. If you could do that, you could do away with, you know, the precision of all this other, and kind of just beam out based on, you know, kind of relative strength.
But if they will turn on the GPS and you're in an open stadium, you're going to get really precise locations.
Yeah,
So
that's a good idea.
That's
yeah, because you're going to be, you know, down to probably what 30 feet or something like that.
Less probably.
Yeah.
Probably
Use beacons too.
Well, that's true. You can do beacons as well.
Beacons instead of public triangular.
Yeah, but it seems like to really do an accurate job of automatically determining location, you might have to add some hardware to the stadium to, you know, at some key points. So what I'm curious about the NTP problem that you started off with. Why not just say, here's when I heard the ultrasonic signal start, and so that's a synchronization point?
because every phone is keeping track of time differently. So if we look at both of our phones and ask what time is it, they'll both give an answer within 1 or 2 seconds.
Okay, but if you said, how long is it since I heard the signal?
So we were initially, that was our plan exactly. We realized our phones were also hearing this ultrasound at a slightly different point in time.
Especially in a stadium.
Yeah, and like my case kind of covers parts of my phone, and so I was a little bit slower on picking up the ultrasound than like Jeff's and other devices. And so we were even getting a discrepancy in when the phones were hearing the trigger. Yeah.
At least when it's being detected.
Yeah, when the trigger is detected.
Yeah. So basically, it's looking for the next closest 3-second interval, and that's when it says start.
But couldn't you embed into the signal some kind of a pattern that there are skips in the tone or something like that, and so you're able to say this is where the starting point is. I'm synchronized. I don't know how accurate they are.
Yeah. So we didn't get into the data through the sound wave, and that is like probably something that we want to research. So yeah, we just
I guess
that one.
the question is what resolution, what timing resolution can you measure presence or absence of ultrasonic signal at? And if that's accurate enough, you wouldn't have to worry about NTP syncing things. You just need to say, okay, I heard the signal and I recognize these variations in the signal at this point.
Right.
That's your marker that you measure from, or something.
Yeah, and we I think just through our brainstorming, we definitely thought of sending data through the wave, but it never seemed like we would be able to get there to that point where we were sending the data through the wave and syncing it, whereas maybe we took an easier approach.
We weren't as confident in the devices. We thought they'd miss the middle part of that. We thought about sending 3 tones and having that be the whole trigger, but we were afraid that this phone would miss the first trigger, the first part of it until it was too late. This might miss the second one. So I guess we didn't do enough testing to have enough confidence in what the phone's going to do.
Yeah. Do you need to have a data connection for this to work on the phone?
So you don't, but it's more accurate if the phone can make the NTP call. So if it doesn't make the NTP call, it would be off by the amount that your phones are different.
How does it know? How does it know what the light program is?
Yeah, you'd have to synchronize at some point. The assumption is, yes, you need data, right?
Right, so we assume that since they're going to be entering the row seed section, that they're going to be using data to just receive the individual configuration for their row seed section.
But it could be ahead of time, is what you're saying.
I see. So at some point, the phone has to talk to your network server to get, here's what the program is for the light show.
Right.
Yeah, especially because the pixels will change. You could get like the pulsating thing that they demoed in the first, but the characters and movement and things like that you definitely need.
Yeah. So we expect that the user would enter their row seed section, and then they receive back like an array that tells the phone like, turn on, turn off, turn on for this long, turn off for this long, for as long as the show goes. And then at the same time, it also makes a call to the Apple MPP server and says, how much different am I from Apple's time server? And so that way, when it starts, all the phones will know where they're at and what the difference is, and then be synced.
Rather than start and end times, if you're doing a lot of changes, I think you're, for a 5-minute show, better off just sending bits for every, kind of whatever resolution you decide on, if it's a 30th of a second or whatever, rather than, sending longer metrics, especially if you have a fair amount of movement.
Yeah, it's something that again, one of those things where we don't know how it's going to scale yet, because we've only been testing in small increments.
I think it has a lot of promise, and I think to reach widespread acceptance of the idea, it's really that design portion that's so critical. And I know we had some discussions, but I'm convinced that you got to have a video that you can overlay, a binary video, if you will, black and white, that you can overlay on kind of the map, and then sample the the seat map behind the scenes. You might be better off not being on the web. You might be able to do it too, but you could certainly kind of do a lot of kind of what's the pixel color there in this thing relative to the position of this other object in some richer environments. Anyway, but I'm convinced allow someone at BYU to create a video, overlay that on the seat map of the Marriott Center or the stadium, and then have it derive the data that's needed, rather than necessarily building out the front end for every possible seat configuration and then frame by frame by frame. Oh,
you might be able to get people to print some code on the ticket for you, or you might be able to put a little token on the seats or something like that.
Yeah,
scan a QR code or something.
Yeah.
And we definitely were talking about those ways that I don't think we ever really got there in our capstone. We had so many other challenges that we also faced.
So do you pursue this still? Are you gonna try to get the Marriott Center with that contact, or are you just too worn out to?
So I think what is viable is like meeting with contact to see if we produce the design show. So obviously we have like our clunky designer that we understand, but I think our first iteration would be us using that to create a show rather than them creating it themselves, because like I think we would learn more about what it means to scale, and as we're doing this, rather than trying to do something that they can create something off of. And I think the iOS app is like we feel pretty confident about the features that we have in it and its ability to do what we expect it to do. Hopefully if we had it branded to BYU, it would be easier to get in the App Store. And then we would also be creating an Android app that would do a similar thing. So that's kind of our next goal.
Other questions? All right, thanks, gentlemen. Thanks.
question while you're walking away. So if you dim the lights in the mirror stuff, could you flip the phone around and have do different colors on the screen rather than the light on the back and do even
We had a
more colors
prototype that did that too.
Yeah. So
you start, you have to have dark, but
yeah, so we also prototyped with that as well. The reason I think we didn't pursue that is because, like, just like it's simpler to do like on and off kind of thing. But it definitely be a possibility, and we set it up so that if we wanted to have that as a feature, we would be able to implement that type of thing. So yeah.
Okay, up next we have Absolute Task, but I don't see Tom or Chase. Okay. They're practicing. Whoa. Bonus points for that. Okay. I'm guessing I know the increased probability. Fortnite versus practice for your capstone presentation. Yeah. Good stuff so far.
Hey, Jason, how's it going?
Good.
Good to see you. You too.
How's it going?
Good. Ready for this?
Yeah.
Awesome. Hi.
but way better than where you guys have to really kind of 60,000 seats, every front.
Well, so yeah, so
Yeah, that's yeah. Thanks for coming. So, you Chase belong to you?
Yes.
Perfect. Thanks.
Yes, he does.
That's awesome. He's great.
Yeah, he's
Super
pretty
fun.
good.
He convinced you.
Yeah.
Goodbye. Goodbye. Okay, anytime, gentlemen, are ready. We're ready. You're on. Perfect timing.
Alright, we're excited to show you guys Absolute Task today. There's a lot more people here than I thought would be, so that's fun. To begin with, I want to tell you a quick story about a guy, your friend named Bobby. Bobby is a manager of a Little Caesar store in Washington State, up in Seattle. And one day, as Bobby was driving to work, his car broke down on the side of the road and he got stranded. Worse than that, His phone was dead, and he couldn't call the owner, Ren, to let him know that he wasn't going to make it to work on time. And so he wasn't able to get the store up and running. Now, on a normal day, Bobby would arrive at 8 a.m., open the store, start getting things ready. The rest of the employees would arrive at 9. And together, they'd have about a combined 2.5 hours to get the store up and running by 10:30. However, on this day, when Bobby didn't arrive at 8, the employees arrived at 9 and found the door locked. And so, being fast food employees, they just sat outside and waited to see when Bobby would show up. After about an hour of this, they're like, all right, maybe we should call somebody. And so they finally called Ren at 10. The store was supposed to open at 10:30. So Ren rushed down, called a few additional employees, made it to the store, got it open on time. But now they only had about 20 minutes to do what normally takes 2.5 hours. And so they weren't prepared for that lunch rush and didn't have operations running the way they needed to be. This story illustrates 3 problems that Ren faces on a daily basis running Little Caesars. The first is efficiency, making sure everything that needs to get done gets done. The second is transparency, knowing about problems when they happen, not when they affect his business. He didn't find out until 2 hours after he already got the problem. And lastly, cost. It cost Ren about $75 in revenue, or in labor costs to get more employees to get the store open, as well as lost sales from people that expected their pizzas to be hot and ready. This is Little Caesars after all.
Now, this is just one story from one unit in Washington State. But Ren, the owner of that store, he doesn't just operate one unit. He operates 5 in Washington State, and he operates 15 across the United States. Operating Little Caesars franchises or other restaurants is very difficult for operators because of little problems like these. When they're not actively in that store, it's very difficult for them to know what's going on, the problems that are going on. It's very difficult for them to be able to resolve them. In order to combat this, companies have been trying to implement procedures in order to make sure these critical tasks get done throughout the day. Paper checklists have been used for a very long time, but the problem with paper is that there's no transparency. Ren can't be at one of his other stores in Washington State and know that Bobby didn't get to that store by 8 o'clock. So in order to combat this, companies today are creating digital checklists to provide some of that insight into what's going on. While they do give you notifications, they give you a little bit of analysis into your operations, they are very complicated. And one of the other real big cost concerns for operations businesses are training minimum wage employees. Ren Brown in Washington State, his yearly turnover is 150%, which means every 6 months, he's training a new employee on how to use these digital checklists.
So this is why we built Absolute Task, with the ultimate goal of making it easier for operations to be able to manage themselves, to be able to go through their workflow and complete critical things, to be more efficient, to be more transparent with their problems, and ultimately to make more money, to lower the costs of working and increase overall revenue based on better service. So the first thing we did is change the way that we view checklists and change the way that we did it. So we went out and designed what we called the Absolute Task Grid, and we're actually going to let you guys run with it, pass this around. There's more to you than we thought.
I've played with it before.
So go ahead, pass it around, interact with it, try and break with it. Try and break it if you want. It's a very simple app. That was the initial goal, was to make this simple and easy to understand. As you look at the picture, you can almost immediately tell what's going on. In 10 minutes, you need to turn on the ovens. 20 minutes, prepare the sheet outs. So the colors are going to help guide you through there and help you know what's going on. Also in the app, if you swipe to the right, you can see a regular checklist that we're used to. But what this does is it focuses employees on what's due next, on what's happening immediately. So not only does it manage the task side of it, but also manages the time side of it. So we keep them directed on here's what's next, and help them through that workflow. This makes them more efficient as they don't have to worry about auxiliaries or what else is going on. They can stay focused on the customer because they know, okay, I have this, that's it, and then they can keep on going. Oh, yeah. How about that?
We broke it.
You broke it. You succeeded. There you go. Feel free to check off tasks too as we go through the rest of this presentation. You can kind of see their outline through that. So to complete it, you click on it, it opens up a form view, then you hit the green check mark, say you're good to go, and then this view will automatically update and show you what's due next. Once again, keeping you focused on what's happening immediately.
So the grid improves efficiency. It makes task management a little bit easier for the end user. But Ren's going to purchase this application because of the transparency that it gives him into his operations. Actually, I haven't checked yet. Yep, there it is. So you can see on the left, this is a notification sent from the tablet yesterday when I didn't complete a task on time. And actually, on that schedule, I don't know where the tablet is right now, but that schedule is geared after this presentation right now. And the first task on it was get to school, arrive at Tanner building by 2 p.m. I got here at like 2:05, and it texted me to let me know that I hadn't completed that task before I came in. This is really what Ren wants. You know, Ren wants to be in his car driving to their store and be notified within 5 minutes that Bobby didn't get to his store on time, so he can place a call and figure out what's going on. When he doesn't get a hold of Bobby, he can go tell his supervisor to go run over to that unit and go figure out how they can get it going, so they don't end up an hour and a half later just finding out about the problem and resolving it then. On top of that, Absolute Task offers a management dashboard which provides some analytics, reports into what's going on, and as well it allows you to manage your schedules and manage your units as well. So we're going to walk you through what we have so far on the management dashboard. All right, so first we're going to sign up for a user.
Oh no, 404. Scribble, scribble, scribble.
That was not good.
Let me ask you a question, Thomas.
Yeah.
He's logging in. Do you have different priorities for different tasks where actions can be associated with certain priorities? Like if something doesn't happen, I might not want to know those things, but if employee doesn't show up and mark off the task for opening the store, that's a big deal to me as an owner.
No, we haven't done anything like that yet. That is a good idea though, like how urgent it is. If this doesn't get done, you don't want a notification.
Yeah.
But if this, it's a good idea. We haven't done anything like that. Right now, if anything doesn't get done within 2 minutes after it's time, it just shoots off a text.
Okay.
In the future, it'll be a management app on your phone as well, so it'll just be a push notification.
Yeah.
And that'll be, I think, a little bit easier to manage as well.
Yeah.
All right, I don't know what that was, but we got around it. So I'm going to log in. It's going to authenticate us and then take us to our dashboard. Now, all of the features of our dashboard are currently one feature, a dashboard component that is just going to show you a report on your current task data. We created an administrator account. So this application has 3 different tiers of users. You have a manager, a supervisor, and an administrator. Your administrator is like Ren. He owns a bunch of Little Caesar stores. Some of them are in Washington, some of them are in Iowa, and he wants to be able to see reports and be able to manage those different regions. Now, this demo account we've created only has 2 units. One is fake Little Caesars restaurant, and the other one's this IS tablet capstone presentation user. But right here, those top 2 quadrants are actually where you would see the current overdue task data. And then as we scroll down, we start to see some information regarding completed tasks, the percentages of on time and what's not, as well as some trends on how many late task completions we've had. So we can kind of get an idea of if our operations are improving or if they're getting worse. Now this application, we actually just pushed it live, I guess, today, and we sent out that link, which just broke, to Ren, our pilot user. So he should be getting on this week, and then we'll improve this dashboard to get feedback from him on what's working and what's not. We also are planning on creating a reports component that's going to give you better insight into the actual task data for a unit, as well as a schedule manager and a unit manager to manage that stuff as well. So that's the management app as it is right now.
Right. So management app increases transparency, lets you get insight into what's going on in your operations, gives you real-time feedback on what's late, what isn't, helps you solve those problems. And the app increases that efficiency. And overall, the combination of these two affect that bottom line, or cost line. We talked about the training costs that are going to go down because you have this guided step-by-step app up in your stores. The cost of labor is going to go down. And overall, you're going to be able to offer better service, and that's going to increase revenue. So the bottom line is we're going to help you make more money by implementing Absolute Task.
The cost of labor is going to go down?
So
wait, you're going to hire people for less money because they've got a great app to work with? What do you mean the cost of labor is going to go down?
So the cost of labor, like Ren's situation, where you had to get additional people in there.
Oh, like overtime.
Yep, overtime, stuff like that. Training costs are going to go down, so the cost of paying your employees is going to go down because you don't have to solve these types of problems anymore.
But if I got one thing to that,
yeah.
On the schedule that he's currently using as part of his pilot unit, or pilot group, one of the things he's constantly having employees check is a labor check. Basically, every couple of hours to make sure that they don't have too much labor in their store. So if they do, their manager can go send somebody home. So like that, they're not currently doing that, but with this, you know, he's forcing his employees to constantly see if they need to send somebody home to decrease that cost.
So he's using it really well. Since he's been using it, it's been in his stores for about a month and a half, 2 months now. He has said the things used to not get done are getting done, stores are cleaner, labor costs are low, and inventory is stocked. This is impressive. His stores have done about 1.5 thousand tasks over the last 2 months. It's just been great to get feedback from him and see the success that this has had in real life application that it's had in his stores. So
is that red?
No, stock photo.
Maybe 10 years ago that was red.
Careful now.
Yeah. So our technology, we're not going to go super in depth with this, but if you have any questions, feel free to jot them down or ask away. Our application is split into 2 different apps. We have our mobile app, which you guys are looking at, and then we also have the management app, which we showed briefly. They're both built using React. The mobile app is built using React Native, specifically for Android. That was a strategic decision to try to make this as cheap as possible for a franchisee to be able to get this application up and running in their stores. And this entire application is built on top of AWS. So we've tried our best to adopt as much of a serverless approach to this as possible. The place where we've been hit on that the most is the data layer, but Amazon has announced a couple of serverless options going forward with Aurora Serverless that we're hoping to implement this year to decrease pretty much 90 to 95% of our costs right now for this application.
Which is really still pennies.
Yeah, which is like $40 a month. So it's nothing, but if we had the Aurora Serverless, it'd be like $5 to $10 a month.
I can ask you, like, if I'm a normal employee, like cashier at Little Caesars, am I able to use this like on my phone? Would I be able to use it on an Android phone to look at these tasks, or does it have to be?
So eventually, I think so. Depends on use case. What Little Caesars wants is more of a team environment, and so the application goes just up in the store, so everybody can see and interact with it. Depending on different stores and what they want, the app is available to go to phones as well as to iPads and iOS in the future.
And then are tasks assigned to like each specific? Are you able to assign it to a specific user, to a group, or how does? I'm just curious on that. This is really cool. Yeah. And I'm just really intrigued by it.
That's one of the things that is going to be version 2 of the app. Actually, is going to be able to assign it to specific users. So that's coming. Yeah, that's the idea.
Some of the things that we learned on the tech side, the first is that implementing cloud technology is very similar to learning a programming language. Tom and I were both AWS certified last fall, which helped us a ton to get a foundational understanding of how AWS works and how to implement it, but we still had to learn a ton in order to be able to get this project to where it is today. So don't take for granted that a cloud service is going to do all the work for you. There's still quite a bit of understanding you have to be able to incorporate all those features together.
The next thing is new technology does not mean extensive documentation. As we did a lot of these things.
Usually means little documentation.
It means almost none. There were multiple times during this project that I was sitting on the GitHub repos for Facebook's React Native or Amazon's Amplify, different libraries like that, where I'm just waiting for them to push a change because there was a bug in their code, and I couldn't figure out a way around it, so I was waiting for Amazon to update something or Facebook to update something. And so really on a lot of these technologies, we were just right on that edge. And there's things that they've pushed in the last 2 weeks that we've now incorporated into these applications. It's been a lot of fun.
Third, cloud technology both decreases and increases complexity. It decreases because we can use certain services and just don't have to worry about it. For instance, authentication. Authentication is completely handled by AWS, which means they're responsible for securing it and for making it available for us. But it also increases complexity in that by using these services, and especially by testing out these services and doing some development with these different services, you create a lot of bloat within your AWS environment, stuff that you just forget existed that you spun up. And if you're not careful, you could actually incur quite a bit of cost. Each month, we probably spend, we actually have about $40 to $45 in cost attributed to our application. We're probably spending 50 to 55 because of just random services that we spin up, forget about, and then we delete, a week or a week and a half after it's cost us $5, $10. Now that at scale could cost you quite a bit of money, so you have to be really careful about those things.
Next thing we learned is that internal documentation saves lives. As you said, there's a lot of breadth to this. We have 2 different applications, a lot of different AWS resources, a lot of different code bases. And if we didn't document carefully what we were doing, that README doc at the beginning of your repo is so important to give you what's going on. Because it was easy for us to get lost. And so if we didn't have written down exactly what was going on in this section of code, it would take us forever to figure out. And so we learned definitely take good notes, document, comment that thing up to let yourself know even more so than people that are going to maintain this later.
And finally, cloud services do the heavy lifting for you. As we talked about with authentication, there's a lot of work that they're going to do in order to make your application a scalable one. This application, we're confident that the current setup could scale to about 50 to 100 units, which means that that's probably close to 1,000 active users hitting this API and hitting the data layer. And really the only thing that we're going to have to specifically focus on is our databases until Aurora Serverless comes. And then that number, I think, will go from 50 up to hundreds or even thousands of units.
So as a part of this capstone, we're so pleased with our progress, we decided to enter into the New Venture Challenge, which was an amazing learning experience for the both of us. We placed top 16, which we felt really proud of. Really, it was a validation experiment for us to see where we were at in comparison with other startups, where we needed to be at and what traction we could gain. And then just the people we were talking to, the judges, the people we brushed shoulders with at the different events that went on that week, and we were able to talk to them about our product, and about our business, and how we could change it, how we can grow. So that was an amazing learning experience for us. And as a part of that, we got invited to the Founders Launchpad this summer to be able to have a dedicated summer at the startup building to really focus on this and try and get it up to that next level to where we need it to be. So that was an amazing learning experience. So as part of that, there's a couple things we learned. One of the things, validation is critical. That was one of the biggest things for us. We were really disappointed we didn't make top 8, because top 8 is when you started to get money. But as we went and watched the top 8 present that next day, it was amazing what validation they had. When I say that, I mean they had gone out, they'd gone sales, they'd gotten contracts, they had deals, things in place, and they had this validated through multiple levels going forward. And really, we realized doing this that we were just about 6 months to a year behind where we needed to be to have placed top 8, to have that more validation and more traction in our product. And so we learned that as we present to investors that having that validation is critical.
The second thing that really killed us in that competition was not being able to sell ourselves with our idea. Regardless of how good this idea might be, we weren't able to convince the founders that we were passionate behind it. If we need to be bought in for one, and then help express that to the people listening to us that, yes, if someone's going to be able to make this work, it's going to be the 2 of us. So since that competition, we've also done a lot of rethinking, looking at the next couple of years and really trying to figure out if we can get behind this. And when we did decide that, really trying to, I guess, get our heart and soul behind it too.
One of the last business lessons we learned is that scope creep is a really serious thing. As we got the first version of the app out and put it into a store, we got feedback every single day, like, hey, could you change this? Hey, could you change this? Hey, what about this feature? What about this feature? And it would have been really easy to just work on those features for the rest of the capstone. But it was important that we did our user test and we stayed on track to our plan. We said, okay, no, we need to have a hard stop on progress with apps so we can work on the web and management portal. So it's really important to us to be able to manage that scope creep and not let it get too big.
So where are we going from here? Well, right now we're in one pilot unit in Washington. Our plan is to expand that once we finish some core features. We're currently almost done with a reports component and a schedule manager component. Once those are done, we're going to expand our pilot program hopefully to 5 units. And we're hoping by the end of the summer to convert that pilot program plus an additional 7 into 12 paying units. And then take it from there and hopefully ride some crazy hockey stick growth to millions and millions of dollars.
There you go.
Tell me about your business model. What does a paying customer mean to you?
So the way it's going to work is that tablet is going to be put in 1 unit of an operations business. That means that someone like Ren, who runs 15 Little Caesar stores, he would pay per unit for each one of his stores to have a unique tablet with a unique account to create unique schedules for that unit. Which means we're going to be a subscription-based model, month to month, per unit that user has.
So pay fixed cost up front and then variable cost by the month? What does that look like though? Price point.
We're actually going to eat up the fixed costs, so it's part of our actual proposition market compared to competitors, say Jolt, where we're actually going to spot them the tablet up front and installation, and then they'll just pay monthly.
And you own the tablet.
We'll own the tablet.
Okay. Yeah.
But,
and how much does that year contract cost?
Maybe figure out it's like
it's $576.
$576.
$576.
So that's about 43 bills monthly.
But think about it, a lot of the options for digital checklists right now are only available on iPad, and that iPad's going to cost you at least $350 itself. So basically, them paying for their iPad could have paid for over half a year using Absolute Task. So compared to any other option they're planning on implementing, this service, we're hoping, is considerably cheaper.
Have you validated that amount yet? Like even through kind of run?
I mean, we've just thrown out numbers, but the sales validation we're hoping is going to come in between this and this.
Yeah. I mean, if you get
exactly what
that,
the price point is.
Really you should hire a sales rep or some sort of affiliate marketing, to implement this and give them a recurring cut of the monthly revenue, and even if you need to bump up your, what you're charging for that, I think. What's Absolute Task at, like $100 a year or something like that, depending on the service. I think depending on that price point, you'll hit really small units also, or you'll kind of weed those out. So figuring out kind of the price sensitivities across industries, I think, may be helpful eventually. But there's gazillions of these businesses that would benefit from this.
So I think you have a real business here, and that's very encouraging. Don't forget that even though you didn't get into the top 8 of the New Venture Challenge finals, you can still get some I-Core money from my NSF grant, $1,000 to $3,000 for validation purposes. So as you have validation expenses, that's something I can help fund.
Great.
Tell me about the quality of Metabase. What do you think of that? I noticed that little logo on the dashboard.
So I won't pull it up, but what happened was last fall, I guess early in the winter, we were trying to figure out how we're going to do the analytics for this application. We knew we wanted to embed a dashboard into our app. We looked at Tableau and Power BI, but the only realistic option was Power BI. The Power BI embedded option came at a minimum of $750 to $800, and we figured for this capstone, that's just absurd, Maybe once we get our first 10 to 20 customers, we can actually offset that cost. But for this capstone, it was just ridiculous. I think it was Grant. Grant's in the back. Grant was actually the one that recommended Metabase to us because you use it internally, right? Your current employer?
Yeah.
Yeah, so he recommended it to us. We did some research and realized that there was a free option we could use as long as we included the footer at the bottom that said Metabase. And so that was just kind of a no-brainer at that point for us to just get started on that. Now in the future, we might switch over to a Power BI, but right now it doesn't make sense for us financially to do that.
And what's your reaction to React and React Native? How have those technologies been for you?
It's been awesome. I've loved the ability to know that my code is written for both Android and iOS, and that with really few changes to what we currently have, it could be up and running on an iPad very shortly. And then just knowing, so I come from a JavaScript background and didn't know really iOS or Android that well. So being able to use that to write an app was really easy and it didn't take too much. Learning curve was more so in things like Redux, which I'd never used before, was where that learning curve really hit. But as far as actually building an application, it felt really friendly to me. So React Native was awesome. Highly recommend it. You can still build really fast applications and get things going. And then it really helped out that we had this base with the mobile app, and then switching over to just regular React for the web app wasn't that big of a deal. So it's been a lot of fun. Yeah.
How did you find your first person to develop that?
That's my brother-in-law. So my in-laws, they run that 15-store Little Caesars operation. And so they were talking to me about some of the problems they had, and I asked them if we could do a capstone project. And it just kind of evolved from a capstone project over the last couple of months into something that we're actually going to pursue. Cool. Awesome.
So speak to that a little bit more. You're thinking of kind of seeing where it goes in the summer? Is that kind of where you're at?
Yeah, so entrance into the Founders Launchpad, we're going to use that as an opportunity to finish out all the core features that we can actually bundle up and then feel good about charging customer for. And then once that's there, we're planning on working nights and weekends on this, hoping to get to the point where we'd be able to quit our jobs to do this more heavily. We believe it's got legs to it. It's just getting the core functionality and figuring out who's willing to pay for that.
Yeah, and I think some of the things that'll make this successful, I mean, you got to have the tech side, but really it's that, word of mouth, the sell side, and other things. I would encourage you to really consider the incentive structure that will allow much faster growth over time. People are incentivized if, hey, it's ongoing, as long as these folks stay with the program.
Are there any other questions?
All right, very good. Thanks. Thank you much. Thank you. Thank you.
Also, thanks to Alec for help on the slideshow.
Oh, yeah.
Throw that out there.
That's fantastic deck. Yeah.
Yeah, that was a fantastic deck.
Yeah.
99% Alec. I was wondering if you helped with that.
Right, up next we've got Brandon and Mitch. Brandon, Mitch, you're up.
Very impressive.
Well, so is your dad happy?
Oh yeah. Yes. Very happy. Keeps a little birdie in Chase's ear.
Okay.
So it's like, what are you doing? What's the next features? I'm like, chill out. It's going along.
That's awesome. Man, I'm gonna have to run upstairs and print some more in a minute of my evaluation checks. Oh, looking for a, yeah, it's probably not going to work with your adapter. Here, why don't you take my cord?
This little.
Yeah.
Got the adapter still works. Hopefully I'm not trying to.
Oh, yeah.
These are not super comfortable chairs, I don't think.
Yeah, right. And there's no way to lock them so they don't lean back.
Yeah.
That's a flaw. So then you have to have this perfect posture.
You have to sit like President Nelson.
Yeah, to actually sit
Did
up.
you notice him in conference? He was
Yeah, on the edge of the
in front
chair.
his
Yeah.
Not leaning back.
I think we're close enough, so whenever you gentlemen are ready, we're within 45 seconds anyways.
All right. We're glad to be here. I'm Mitch Hussey. This is Brendan Buchanan. We are working with Dr. Little on the LDS Scripture Citation Index, doing some user testing and some design work. We're excited to be here today. So just as an introduction, Dr. Little has been working on both the website, Android, and iOS applications for the Scripture Citation Index app for quite a while now. And he's had a lot of revisions and built a lot of power into it. And what it does is it allows you to view all of the citations for a specific verse, if they're in a general conference address or some of the other publications from the church, so that you can very easily see what general authorities and other church leaders have said about those specific verses. So it's really powerful and it has a large user base. Where there's a lot of different people that have downloaded the app and been using it for years. But one thing Dr. Little has talked about is that he hasn't been able to do extensive user testing with large groups of people. So that's where we offered to come in and help him and use some of the things that we've learned throughout the MISM program to help benefit his app.
So we kind of first started out by doing some analysis on data that came from Flurry. So he uses Flurry. It's a data analytics engine to collect what the user's doing within the apps. So some of the numbers here. So between January 1st, 2010 and April 8th, 2018, so in like the last 8 years, it recorded 558,000 new devices and 7.3 million total sessions. So huge numbers. It was really cool to see that, like that, in a way the app showed that people, I mean, there's a reason there's the apps there, people want to use it, and that people were downloading it. So those were big numbers. And then next, that kind of showed the problem that we saw is after seeing how many people used it, is in that same time period, the median session length for a user was 100 seconds. So for those millions of sessions that were there, they were only spending a median of 100 seconds.
That's a problem.
Yeah.
Is that too high or too low?
It's too low, we would say. Especially for what the app was designed for. So, and then the next number.
Maybe they get to their data so quick that that's all they need it for.
It was a possibility, but for how long some of those addresses are, we were skeptical about that. Another thing we looked at here was the percent return per day over the 2-year period. And so a lot of the users would use it for 1 day out of the month per se, and then wouldn't return, right? It's a huge on the install day, then very few users would return.
So this is normalized to the install time. Okay, got it.
We did see some interesting trends though, where people would install it and they wouldn't touch it.
And then spike later?
At first we were like, what are these spikes? Because it was like huge amount of users, not very many. Huge. We found out it was Sunday.
Yeah.
Where people were doing study in the app. So.
Yeah. And obviously this is aggregate data over the 2 years, so it smooths it a lot more. But ideally, like this is what kind of formalized our problem is that users can see like whether they hear it from word of mouth or see it in the app store from classes here at BYU campus. They have a desire to install it and see a need for it, but there's something that's happening that's not keeping them there.
So with that, here's how we planned to approach the project. We planned to do some preliminary testing with the current version of Dr. Little's app on iOS and Android so that we could see where there might be some snags people were running into and how people interacted with the app and get some feedback. We then planned to do low fidelity mock-ups and do a few iterative rounds of user testing as we made modifications to the low fidelity design and built it out. And then to finish with a high fidelity design that felt like an actual application and where we could really test it and see how people reacted to it.
So one of the first feedbacks we got from some of our testing is that the home screen opens to this, where it displays the scriptures, the name of each of the books, and the citation numbers. And a lot of the feedback came and said, this is really busy, I'm not sure what I'm doing here. And these are people that haven't interacted with the app before. And they just thought there was a lot going on that was kind of unexplained and they didn't quite understand. So, so people would spend more time trying to go through the app, trying to figure out what's going on before they could say, okay, like, this is what I'm going to use this for. So
should increase the session length, though. That's
yeah. So
so there were a few things that we noticed as we did it. First, with all of the options, it made it very fast, and it cut out one additional tap of having to get into a specific book and chapter. But sometimes if we said ether was what we tested, and a lot of people would kind of be scanning back and forth, and they didn't know exactly where it was in the Book of Mormon, so they'd kind of be going, and then they'd scroll back up because they'd lose confidence and think it was in the Old Testament, and they'd go back and forth a few times, and then they'd eventually get it. And again, this wasn't something where they were spending 10 seconds, but instead of tapping and immediately tapping to the next, there was a little bit of a hunt for it. So we saw that there was some potential there. And one thing that people were a little confused on was in the navigation bar on the bottom, there were a few different options. There was the citation index, and then a context tab that had some of the other readings that they could do in a cited material. People didn't know why those were in two different sections, so that was something that we tested with, and we'll show you in our design momentarily. So a few other things that we saw in preliminary testing And these were things that people either asked questions about or when prompted said that they didn't really know what it meant. There were a lot of abbreviations and numbers. In each of the tiles that you can see here, there's a number saying the amount of citations that are included. And with the size of the tiles, it wasn't possible to expound and say that it's 28 citations. Once we explained it to people, they understood. But on first use, a lot of people didn't know that. And then we also saw in general conference with the O and the A, some people it clicked and other people it didn't quite click, that it was October and April. Those were a few instances where we saw where it's very valuable information, but if the user didn't have an explanation to it, they didn't necessarily understand that value in it. And then another thing is Dr. Little has a very powerful search engine in it. A lot of people were overwhelmed with the different options if they clicked the show options contained in the app. And so we began to brainstorm and try to come up with some ways that we could potentially make searching an easier experience for users where they'd be more willing to use that functionality.
And then the third thing related to that search was two kind of fundamental things we thought a study app should have. Is one, the search functionality, which Mitch kind of just addressed, but the second was bookmarking, which Mitch kind of discovered that initially on his own when he was trying to let's test out bookmarking. He said it took him about 20 minutes, half hour.
It took a little while.
And the problem was because when we talked to Dr. Little about this, but when the app was, when he'd been using it, the bookmark, when you click the bookmark, it would show up right here. But for some users who have a variety of apps installed, this would be over here somewhere, and you'd have to scroll horizontally to go find it. And so it just wasn't in a traditional spot to look for it, but it was for users who have a variety of apps on their phone, it would be a different experience for each one.
What was really interesting is this was where we saw the iOS and the Android difference be most apparent, because I was doing the testing myself, and I was like, I can't figure out how to bookmark this, Brennan, and he was on his phone. And within 30 seconds, he was like, done. And I'd been sitting there for about 10 minutes, just trying to figure it out. And we saw and we tried to mimic some of the Android functionality on how to bookmark. And in our test with other people, we saw on iOS it took significantly longer than that Android functionality. There we go. So in case, yeah, that way, so you can see it has it here, but then I'm not that, so we can show it. So we began to do low fidelity designing and testing.
Yeah, and so we decided since we didn't really have an exact direction to go into, we decided to implement like an A/B testing methodology with this. And so we decided one overall task we wanted to tackle was to try to improve navigation. Our theory with that was that if we could improve navigation, users would be able to get around the app a little bit easier, and they might be more apt to stay on the app and to be able to use it because they would be able to find the content they needed. So in this case here, our A/B that we used was one, we decided to use a list type view there in the middle, which is similar to a lot of different menus and things on mobile phones, both Android and iOS. And we thought it grouped together and simplified the books that way. The second one was we patterned it after Gospel Library. We used kind of a cards-based method. We thought this could be good because majority of the users that would be using this app have used Gospel Library, would be familiar with that pattern.
So with that, we also were trying to figure out that bookmarking on top of the design, how on iOS we could make it a little bit easier. And this was where I found out that what's intuitive to me is not necessarily going to be intuitive to the users. So it was kind of interesting. I put an indicator in the top right where the share was and where on Android it had the little menu icon where users could click and bookmark. So I put a little information button right there and then had a kind of information window that would pop up, and the top of it being to bookmark that content, and then share, which would bring up the same share menu that Dr. Little had in there before. But I found out that people with all of that information would hit it, they'd scan through it and miss the icon with the book that was bookmarked, and hit cancel and go back, and then they'd hit the bookmarking tab that was on the bottom navigation bar. So that was something where I was like, oh, like, I fixed this problem, and then we tested it, and it was like no one could do it the way that I came up with either. So we found out that we needed to go back to the drawing board and come up with some more ideas, and we found out that Dr. Little had been doing the same thing, and found some really good ideas that he had with it as well.
And so some other takeaways that we had was, it really surprised us, but we had overwhelmingly the most negative response was to the list view, is that most users did not like it. They said it seemed archaic, didn't follow after patterns of apps that are using. So that was one of the main things that surprised us. Really positive response to the other one, to the gospel library one.
So let me understand that middle, version of just straight Lisp. Folks didn't like that.
Yeah. And so we thought that'd be really simple, but a lot of people came back and just said like,
And even though their perception said they didn't like it, did you get some metrics on timing as far as efficiency or something?
It was still pretty efficient, but almost everyone, when we asked them what they thought of it, said, I didn't like the way that it looked.
Interesting. Okay.
Yeah.
Surprising to me too.
So I think it was more from like a design standpoint than a utility standpoint.
Yeah.
And then also, like you mentioned, the bookmarking, even though we redesigned it, it's still what we thought was good. Didn't turn out to be good in practice. And then they all commented that they really liked how snappy the app was, because we tested this along with the original one as kind of a baseline, and so people liked the app itself, but they did say they were looking for like a little bit easier features to use it. So there was positive response to the actual app itself. But to our mock-ups, they overwhelmingly preferred the tile and navigation setup.
But I think that's where we saw that speed really is the benefit that this application can have over other things, where you can get to a lot of content very quickly. You don't have to wait for things to download. You don't have to wait for images to load in. It's really fast, really snappy, and people enjoy that. And then we also got some really interesting feedback for things that we didn't even think about, where users were like, it'd be really great if we could see what was being cited, like if on Ether chapter 2 verse 3 we could see a preview of the conference talk that was citing it, so that I could tell if that was worth going into and reading or not. That was something where we were like, that's genius. And we had a few people come up with it, and none of us had had that idea previously. So then we moved into the high fidelity testing. And this was where we really built out our mock-ups and tried to have a visual quality that would match Dr. Little's app that was out, so that people felt like it was a real application. And so here, just to walk through, is kind of the step through of getting to Ether chapter 2 verse 3, which was one of the paths that we asked users to go to, where they had the tile layout and they could see all of the content, each of the different books. And with bigger tiles, we were able to expand that text to say that it was citations. And it was just dummy data, so they all say 194 citations. But we were able to fit that in there so that users could understand it. And then we also added a view where you could see the scriptures text with the citations in line, which was a little different than the iOS app, but mimicked more how the web app and the iPad app were able to function. And then we added in those previews so that people could see the name of the talk, who gave the talk, or whatever it was coming from, and then that excerpt. That was something that we thought was very beneficial. In addition, we also simplified the tab at the bottom, where we had a contents tab with the scriptures at the top, and then the modern works down at the bottom, which was what was previously on the content tab. And then a bookmarks tab that was combining the bookmarks and the history icons that were previously in the navigation, and then the search as it was. And we saw some pretty positive reactions to that. And then also adding in a box that showed the verse that the citations were referring to and how many citations there were, and then drilling in and having a more in-depth view. Pretty positive.
So the second thing that we added in the high fidelity was a new search bar. in the previous testing, we had a lot of people that when they got confused would instantly go to the search function. And then in the search function, well, in the mockups wasn't functioning, but in the original app too, is that people weren't getting the results they want because there's a lot of results that would return. And so in this way, what we did was we decided to add a search bar at each screen. And as you would drill down the different levels, so you go into the Book of Mormon, Ether, General Conference, and things like that, is that the search bar would maintain up there, and that you could search within that scope of view. And we surprisingly, in this step is users overwhelmingly tried to use the search functionality. And this was especially true on screens that had more unstructured content. So such as General Conference, about 95% of the users, when we told them to find a talk, since they're not in any sort of alphabetical order or way that we can understand, we asked them to look up the 1994 October conference, which we're not familiar with. And so they would scroll for a second and then instantly reach for that search bar. And that was really insightful that just having the feature more apparent to them made it more usable. It made people more apt to jump to use the search.
And the way that Dr. Little's app currently works is when you go to that search bar at the bottom, in the show options, you can filter what content it's going to search. And you can filter it to only search General Conference addresses or only search the Book of Mormon. But we realized that users weren't really going into that. They weren't really doing it. And that's why they would search for the words that they put and give them a ton of different options. And so by making it where they still have that powerful search capability, if they want to go into the menu item, but then having a hierarchical kind of search that's depending on where they are in the app, it was actually really cool to see as soon as we put that in, that almost every single user we had test hit the search button, which would pop up a message that said, this is a prototype and searching is not enabled right now. But almost every single user, as soon as we put it there, was hitting that button.
So, and then the last thing was we redesigned bookmarking. And so we went with a more traditional bookmarking icon there at the top. We also maintained the bookmarking at the bottom, both of which would open up a new bookmarking screen. A lot of these cues we took from was after meeting with Dr. Little, and he was working on his own implementation of bookmarking, is we kind of came to the same solution together, is bookmarking needed to be more straightforward. So in this case, users were a lot more, showed a lot more positivity towards bookmarking, and were able to accomplish the task a lot quicker, just because it was simplified, and the bookmarking was done in a way that was follows after the pattern more apps that are out there.
This one we still had a lot of discussion over because as soon as we put it in the top, there were still people who would hit the bookmarking tab on the bottom. And if we removed it from the top, people would still look at the top. That was where we kind of thought, does it need to just be in one area, or is it okay for there to be a bottom option and a top option because the users are so divisive on this? That's where when we talked to Dr. Little and saw some of the things he was working on with combining the bookmark and the history, we thought that that really was a good way to help the users be able to do it most effectively. So with this, you don't necessarily have to follow along, but if you wanted to on your computer, on your mobile devices, well, you can go and test the app, and there's a few different paths that it explains. We're just going to do a quick demo showing some of the functionality and animations within the app. So when someone follows this link, I'll leave it up there for just a second. It takes them to Envision's prototyping tool. They have a mobile application where this works a lot better, but it is able to work in Chrome or in Safari, although sometimes there's a few little bugs that are just on Envision's side. And that way people can kind of tinker with the app. This is what we use as we did testing and we did screen recording on our Android and iOS devices. And looks like to just show you briefly and then wrap it up for questions. So when you follow that link, it comes with a little intro message that I added just to show the paths that people were able to follow. And then once you go through that, our first was to go to Ether, chapter 2, verse 3, and view the citations on that app. So in doing so, there's a lot of different options you can see, and it mimics the functionality of an application. Going into the Book of Mormon, Ether, chapter 2, and then going down and being able to drill into versus 3 citations. Once they were there, we asked them to go and read what the dog's up and not actually read it as if they were going to. We had that functionality built in. At that point, we asked them to go to October 1994's General Conference and find the book Priceless Principles for Success by Claudio Costa.
Acosta.
Oh, Costa.
Costa. So this was where we saw the benefit. When we tested the normal app, people would click the citations button in the top left to go home, and they would kind of look around for a minute and they'd say, I don't know where General Conference talks are. So when we combined it, we were able to see the people very quickly. We were able to come in here, hop into General Conference. Here we had it sorted by year. Instead of showing October and April in the same view, again, it was one more tap, but we thought that it made it a little bit easier for users to scan. And then we could have odd and even on one side, make it a little bit easier. What's in there, we gave them the April or October option, and then the tiles for the tops. Once they were there, we had them bookmark it, as we talked about before. That was where they could either click up here or they could click in this bottom section, and it would take them to a bookmarks pane. Grab the bookmark, say OK, and it added them there. Sudo, go and type twice for them. And so it was a really cool experience as we were able to test people, and we would invite you guys if you want to poke around with it. You can do that, and we're going to be collecting the feedback that we have into a report for Dr. Little.
So just some of our kind of feedback we got from the high fidelity testing was, like we mentioned, the search is that majority of every user we tested at some point tried to reach up and touch that search bar. It seemed to be as soon as they felt like they were in an unknown place, like they didn't quite know where to go next. That search bar was kind of there for them. Next, bookmarking accessibility was largely improved, and people responded much more positively towards it. And we were, from what we observed in the recordings, is that time also decreased significantly from people wandering around trying to figure out how to bookmark. We also received really good feedback on the citation previews, is that users felt like it gave more context and they were able to choose a citation more clearly if they wanted. And lastly, like the updated look of the app.
The biggest praise that we saw with this is people said we had individuals who said they would use this over Gospel Library, which has, I imagine, a much bigger team and a lot of user testing. It's a really well polished app. But people were saying if it had that power for them to do the deep dives and really read conference talks that were relevant to where they were in the scriptures, they were able to do it quickly, that they would use that for their personal study. And that was something that was just high praise for what Dr. Little has been able to do, and really showed us that with some modifications to the UI and the UX for the users, it would be their preferred method of doing deep dives into the scriptures and really preparing for talks and other lessons. So lessons learned as we went through this. The first is that the users know best, but their actions speak louder than words. It's not necessarily what they say, it's more going through and seeing what they do in the app that you can really learn from. Now, some of them did have really good ideas that they vocalized to us, but we really just learned a ton by watching people and watching the videos afterward of when they were scrolling around and when they'd go somewhere and then back out. And that was really beneficial.
Second thing was that user testing was a large-scale project. So sometimes it's simple to like look in the app and say, oh, like this must be easy to test. I'll just go give it to a user, they'll tell me what they like and don't like, and then I'll fix it. But like Mitch was saying, is like understanding what the user actually knows and what they want is where it becomes really difficult. And it took a lot of time to find people, to figure out the best way to measure things, to figure out iterative mock-ups, to be able to create the best features to test that would tell us the best way to change it. And so overall, user testing just became a lot bigger project than we envisioned. But it became clear to us as why a lot of companies don't invest as heavily as they should in user testing.
Another lesson is that simplicity and power don't necessarily have to compete. And with the search functionality being overwhelming, that was where we put our heads together and we tried a few different ideas of potential ways where those filters that were already in the searching could be used where the user didn't necessarily have to think about it as much. It was more natural in using the search functionality. And so that was where we saw that you don't necessarily have to take something extremely powerful out of your app to make it easy for a user to understand. Sometimes you can just come up with different ways in design to make it easier for the user to digest.
And last was that we figured out that users really expect patterns. As users use a variety of apps, they all expect the apps to operate in somewhat of a similar manner. And so, like in the first time when we made the bookmarking feature, is that we were kind of just shooting from the hip with that one, and users didn't know how to react to it. But when we followed more established patterns, users instantly knew how to interact with it. And so overall, it's like our lesson from that was not to get too creative too quickly, and that to be cautious with creativity and only add it when it's needed.
So with that, we'll open it up for any questions.
Well, let's give you a round of applause first. Lots and lots of work. Who were the populations, or who did you go out and do your user testing with? What did you finally settle on?
Our largest population was college students, but outside of the IS program. We found great success in taking candy bars to the Wilt, and people stopped much more frequently than we imagined they would for a candy bar. On top of it,
yeah, I was going to say, on top of that, we also used conference weekend when we had family and extended family around to test some people in the older age groups that interact with the apps, because obviously that's different. And so that was a lot of our high fidelity testing was a mixture of college students, but also a variety of ages as well.
And all new users?
For the most part. There were occasional users who had used the app in the past.
Yeah.
But most people had used the web version that we had talked to.
Yeah.
The mobile, they were mostly.
And you had talked of going to the seminaries. Did that end up not panning out?
That was something we had approved, and we were talking to the seminary, but they only have like a 30-minute window during lunch at Provo High.
Yep.
And so as we talked about it, it was just hard logistically. And by the time we had people understanding what we were doing and did the testing, we'd probably only be able to do 2 people every day.
Understood.
So,
and I think that goes back to the figuring out user testing as a large project is that we have these great ideas of testing different populations, getting all this data, but coming down to it is it took a lot more orchestration and effort to figure out who those populations were to get them. And so I think it was a poor choice, but by default it was easier to go sit in Wilk and get students that way. But we still were able, we felt like, to get a good population to test.
Sounds good.
Is this division between high fidelity and low fidelity kind of standard as you're doing interface design? And if it isn't, why did you do it? It doesn't seem like it's that much harder to make it high fidelity than low fidelity because you've got to still do the design.
As we talked in Dr. Anderson's class, we learned that the low fidelity, where you're not caring about colors or shadow or the shape or anything besides the placement and the text, it makes it a lot quicker to get a prototype out. Now, in the past, what we've done is we've literally on pen and paper gone through and drawn it out and done testing that way, which is much faster. But with the complexity of this and the amount of papers it would have had us having, we decided that just the stripped bare bone would be the most beneficial in Envision, and it would incite more feedback because people at that point wouldn't feel like they were hurting our feelings by telling us they didn't like something in the app. They could very clearly see that it was a prototype. So that's where the benefit from that comes through. They're able to get a lot more harsh feedback because people don't think it's been worked on very well.
It's a deliberate strategy.
Do you have any more time?
No, we're actually out of time.
Right,
Great job.
Thanks, guys. It was a lot of fun to have you work on it.
Yeah.
Is your
you get
search
to implement
capabilities on
everything, right?
mobile, are those all local, or are you having to go out and do those searches, online somewhere?
It's done locally. This is the Lucene open source search engine.
Okay, I was going to say, because otherwise, you know, that might mean increase in infrastructure required.
Is that the last one?
No, one more presentation on a course redesign, which is fantastic.
We'll set the
Yeah.
we'll set a debrief together. And we'll provide you.
We're doing a report that has a lot more fleshed out stuff.
Cool.
Okay.
Great.
Sounds good. Thanks.
Crying for a second. So I don't know if you saw that.
Here's your.
Oh, thank you so much.
They've already done the MISM Capstone. Oh, you have it. So if I were to send that out,
The second part, the reason I have sympathy was just that Joel's her stewardship goals to make sure that all the second leaders start to connect the dots and contact the connections and now the watch list and ready to and so she's saying that when we get leaderships, everybody's on that list. So all I guess.
and I'm fine taking it up a notch. So it comes from you now, so it's
Well, I've always asked them, all of my students, so what's the next step? They want responding to you. Want me to call them? Want me to staff them? I've always said the professors and
Evaluation sheets.
a little bit of everything.
well, we got a spreadsheet that was there, that was there. Shows you the feedback, what you guys
I'm not gonna email it if you got half of it. Okay, I'll do it. I'm sure there's one more on
Nope. I ran it out. So.
the number that I need. So,
You're probably out of papers, aren't you?
Yeah.
No, no problem.
I'm not over I'll get you an evaluation sheet in just a minute.
It sounds like we got enough other people evaluating it. But
yeah. Unlike the
okay.
the variance. So Dagan will be back in just a few minutes.
Okay. I'll go ahead and keep a pen then.
Okay.
Been looking forward to heckling this group.
Yeah, no kidding. So I ran out digging some. No, it'll be here in just a few minutes. I'll get you one too. Thanks. So we're ready whenever you guys are. No pressure. Okay, so this is a IS 555 course redesign. Working on analytics.
Okay, sounds good. So yeah, this is our IS 555 revamp. And so we've got Johnny over here. Kind of get started. So our agenda for today, we're just going to talk about a little bit of why we kind of decided to do this project and what our initial plans were, and then kind of how that evolved and how it changed over time and what actually we were able to accomplish, and then some of the results that came from that, and then the impact that we felt like we were able to have afterwards. So we're just going to cover those things.
So I'm going to set up a little bit of a premise for the project. And most of you are faculty, so you know the situation of always being faculty courses. But I wanted to share just a quick personal experience. I took Dr. Dean's class, his 555 class, a year ago, and then I interned with Exxon that following summer. And when I finally figured out what they wanted me to do was really similar to what we did in his class, I sat down on my computer and I thought, I just need to get MISM Writer, and I can do this. I just need MISM Writer first. And at Exxon, you cannot download anything. And so, like, my only access to MISM Writer was downloading it, so I couldn't do that. So then I thought, okay, I have a little bit of experience with Azure. I'll give that a shot, and then Exxon selected that as well. No development project. So we started to recognize a little bit of a gap between our experience with different tools that are commonly used in the industry, and along with the understanding of the algorithms, that foundational understanding of training the model and then implementing it. So what we wanted to do is to update the course to match some of those hands-on, hard technical skills along with that foundational understanding of the algorithms. So that was our idea coming into it. And then fortunately, Dr. Dean was kind of a step ahead and was already thinking that as well, so we just were able to get more with that.
Yeah, so basically our initial plans in the beginning, before the fall semester ended, was revamp the course for next year. But then a couple weeks before the semester started, we got word from the that he wants to revamp it for this semester. So we were like, oh shoot, okay. So
He moves fast. This is good.
So basically we had to start creating our teaching models at that time. And as students, we noticed that a lot of professors started using a My Educator for the textbooks and everything like that. And we felt like that was a good structure to create our teaching modules and to upload our tutorials. And we decided to use My Educator to have all those teaching courses and modules on our website. Other than that, we want to incorporate Azure and also with R and Python. Becky will explain more of what we actually did, but we thought those were pretty good industry-used tools for all the students to be able to know this concept and to do this data mining works. And at the same time, the most important thing that we want to do is have personal weekly meetings with Professor Dean to be able to have that iterative meeting to decide what we need to do, what we need to do every week to help these students learn, to know the concepts, to know those data models, and also be able to have feedback from the students and what they want at the same time.
I was going to say, just to add on to that, I think this is kind of a build-off too as well for what Professor Keith has been doing for the 415 class as far as teaching predictive analysis. And I know a lot of what he's done before too is in Azure, and so that was kind of like a prepping the students for coming into this IS 555 class. So that was kind of our goal, the idea is kind of move that transition over to that next step to really dive. He kind of showed them what the algorithms were doing, but then Professor Dean would dive in and show exactly like how those algorithms and all that was done.
So we were a little bit off kilter when we found out we were going to do this semester, and so we had to jump in with some initial decisions, and those were to hold off on using Python for this semester and instead introduce them to some R. We decided that because right now in industry Python is really up and coming, but for now R is still at the first place. And then along with Azure, we also decided to keep using Azure. And we also decided to implement a tool called Jump, JWP. And we'll show you a little bit about what that looks like. And part of the reasoning for that decision was there are students in the class that are not IS majors. And a tool like that is kind of similar to MISM Writer, like we used previously. But it's more approachable to learn for those students who are not IS majors, to learn some of these conceptual ideas of how a model is trained and ran. So what we ended up doing, kind of the pattern we fell into, was the three of us covered a lecture, one of the lectures each week, so 2 a week, and we switched off with Dr. D. So that meant we were creating a reading material in My Educator, and within that reading material was kind of walk through examples. We put them data sets and steps that walk through to practice some examples, and then we also filmed quite a few videos, so we could use those tutorials as well. And then we created the homework assignments and recommended data sets and examples for Dr. D to use in class. So these are just chapters that we usually get to in my educator, about a dozen of them. But we'll jump over and show you just kind of an example of what it looks like. This is the course, and you can see the different chapters, the different topics that we cover. So most of these are, you kind of start out the semester with the basic topics that you need to understand before you can use algorithms, and then each chapter is kind of dedicated to a specific algorithm. So that's what it looks like. We go into one of the chapters to see kind of the depth. They had usually about 5 or so sections, and most of the time there were videos that they could walk along. So anyway, so that's what the pattern we kind of followed.
Okay, so with that iterative approach, we were able to get a lot of feedback from the students, especially during the course evaluation, which Jason and I were able to spend a couple of days with the students and to help understand what they need, what could be better, and other than that, we were able to know that the students really enjoyed the textbook and the materials that Jason and I and the first year were able to embed and provide for the students. But at the same time, there were certain things that we could improve on, such as the homework and also the quizzes. There were certain times in just the format of the quizzes and the homework that points were not really allocated efficiently in the homeworks, and also maybe students would be deemed on certain portions of the homework which they spent a lot of time on. So we were able to meet with each other, discuss, maybe we could work out this way, maybe we could work out this way, that students would be able to, do this part of the work and maybe get graded for it, and things like that. But other than that, good work out of everything. They wanted more R and Azure, which we were able to compensate for that after they were able to develop the course foundation.
So we're just kind of going to go over, highlight some of the projects that kind of came out from what we taught the students. We thought that would be kind of cool to just show some things that how they were able to apply what we taught them. And so I think that was
So I chose to highlight a team made up of non-IS students, and the tool they chose to use for their project was Jump. And I met with the group a few times to kind of help them with their project and help them kind of practice a little bit, I guess. And it was really, really cool to see them use the tool to support their understanding. And so in my times I meet with them, I'd sit down and have her, one of the students, teach me what she had tried to work on during the week. And they just did a really, really good job at being very thorough in their analysis. A couple things that I felt they really kind of really well on was looking for correlations in their data. And their data set was a little bit complex, so that was impressive to me. And then also going through the steps of identifying the variables in the data set that were statistically significant. And it was cool to see that this tool supported them in doing that. They felt confident using it, and it was able to support their understanding as well.
Cool. So I decided to go with a group of IS students that did it on the MBA. And this is my natural habitat right here, outside of school. So I love it. I love it how they were able to have a lot of questions regarding about playoff seeds, who wins the championship, salary base on stat line, and what do you call it? Yeah, which teams would make the playoffs. So they were able to run a lot of models, spend a lot of time to be able to look at what are the significant variables on for the playoffs this year, playoff seed this year, testing for championships, testing for salary, and all those were able to get their conclusions and predictions. However, what I really liked about it is that even though they put winner for the Toronto Raptors, there's will they really win? Me personally, I mean, don't think so, because there's a guy called LeBron James who's been in the finals for the last 8 years or so. So they were able to make that conclusion and also talk about it. So that's what I really enjoyed about their project. And also about the predictions of the salary. I mean, they predicted and had those projections of the salary of Paul George and LeBron James and those numbers. But LeBron James, he's making over $30 million a year. So they could maybe, and they also talked about, maybe we could put in another variable like all NBA teams or all stars, because those could raise those projected salaries higher. So, yeah.
Then there's another one, just real quick. Another group we thought was really cool.
So for a company, they were trying to predict the call center volume, and so they used Jump kind of program that they did. And this what was real neat was before the company was just using a standard MLR model, and so they were kind of showing right here they were just getting a low R squared and a very high RMSE. And so after trying some of the different algorithms that we taught them, they were able to up that to like the best was 0.814, and they had they dropped their RMSE. And so just by that, they were able to help the company with their predictions. And so what I think is cool about that is like there's like immediate impact there, because then afterwards they went into Azure and automated that, created an API so that they could use that to make the decisions a lot quicker. So this is just an example how a group was very quickly just using what we learned how to help improve the business and how they could help reduce their costs, and they can help predict when the call center is going to go up, when it's going to go down, how that fluctuates over time. And this was all just based off of what I thought was neat is they had only a couple variables, and with that they were able to kind of feature engineer those variables, break it down, and so they did that. And there are some other teams, I think that you said, that use R to like take in their do data cleaning, manipulate the data, they did it the way they wanted to. So we thought that was awesome.
So now I'm going to show you a few examples of the tools we're using. So I'll show you with John. John will show you Azure. Chase will walk you through with the pod. So hopefully this just gives you a taste for the experiences that the students have. So maybe imagine yourself as a non-IS student looking at this and see if it feels a bit more comfortable. So what I'm going to do is just do a quick linear model and do a increase button, and you select your outcome variable, and then you select all of your variables, run the model, and there you have your results. So you can already see visualizations immediately. You can see the variables that went into the model and see their effect on the model. So what we saw was helpful to the students in this was just getting immediate results and seeing the steps of selecting the variable that they predicted, selecting whatever variables they feel are going to support the model, adding those to the model, and including validation data sets. So that's just a great example.
That's my kind of final project right there.
So part of the data mining and the analytics process is cleaning data, and that could be pretty frustrating at times because there's a lot of manipulating that you have to do. And Azure actually has a certain feature that is really helpful in that kind of cleaning process. So for example, here I have this homework data set right here, which just has prices of the homes and then certain variables like bathrooms, dining rooms, and the square footage and so forth. And what's helpful with Azure is that it has this clean data in this info. And with that, you can select certain variables in which you can remove the entire column. For example, I did it for this one, in which I removed specific variables which maybe are calculated issues with our models, which would get better prediction with it, or maybe there's a lot of missing values in that variable, so it would be better to cut it out. Other than that, you can also substitute variables, and substitute certain things like and right here. You can also place certain numerical variables for the mean of it, and also remove certain records that have just way too many missing values from certain records. You just replace those and just delete them from the data set. And other than that, you can also convert it back to a CSV file.
That, and then we did 2 days on R, and so I got to help teach those days. So that was fun. Getting into like professor a little bit, and so it was pretty cool. So this is just R, the environment that the students have, and it's R with RStudio, and so R kind of plugs into RStudio. R is the programming language. RStudio is the environment in which the students work in, and I think it's really neat because it's like here, all your code comes here, your output kind of comes down here, and over here to the right, you can pull up all your images and charts and stuff. And then right here shows all the variables that you created and where you stored them in memory. And so I guess our challenge was some of the students had never programmed before, and so we had to figure out a way to like help get those students into learning how to program in R. And so before in our material that we showed my educator, we have all these little scripts and that you can walk through piece by. That's what's great about R is you can walk through it line by line just by hitting Control Enter, and you can walk through line by line and actually see the code execute and run as you go through. So we've made sure to like comment it out very well above like each thing, and then so that as the students can read it and then run it and then actually see what it's doing, it help them kind of walk through that process how to do R. And so it's cool. Like example I made here, this open it up, Zoom. There's a correlation matrix right there, showing the collinearity of the different variables. So we did an example of the Titanic. It was kind of cool. Basically trying to predict who would and who wouldn't survive the Titanic. Sounds kind of morbid, but a lot of data scientists kind of start off with this data set. And so basically we showed them kind of how to walk through this whole process, evaluate. And then on Kaggle, there's always competitions, and you can actually upload and see how well you perform. And so we walked all the students through how to actually do this and submit their results to Kaggle, so that way just kind of get them used to that process. They want to take it further, they can do that. So that's just a quick. I won't go through all of it, but just walking it through line by line, how to manipulate the data and that stuff. So. Last bit, just kind of the impacts and the lessons learned that we got from all this. And what we liked about this project is that we feel like there's going to be like immediate impacts. You know, the students are already learning material. It was quite the rush to keep up with it all because since we were doing it as we were going, it's like we had a week to make sure we get the material in, upload it to my educator, all the homework assignments prepared, the slides ready so that Professor Dean can be ready to teach it that next week in class. And so, in a sense, I think that was really good because that helped us stay on track with everything from week to week. So we learned a lot there. And I felt like it was better that we actually did it while teaching the class because that way we were able to get immediate feedback from the students rather than I think we would have done it for the next year, we wouldn't have got as great insights as we would have this year. So I thought that was really good. And so we felt like students can walk away with better understanding of analytics. Students can become more marketable knowing some of these extra tools. So they know Azure, a little bit of R, and Jump. And so that way if they're going in for interviews and if they're asked what kind of experience they have, they can kind of get some examples. And then my educator, they'll always have it, so it can be a constant resource. And I think over time it'll continue to get better as well as time goes on. So it was a really fun project. I think I really enjoyed it. And so I'm sure that was helpful too as well. But it's been a great experience overall. So that's pretty much it. And so yeah.
Well, let's first clap.
Yes.
I have comments. I think that one was really fun and a lot of hard work, and the students did really, really great. I would write basically a module a week, and they would write a module a week, and then I would edit the module, and we kept cycling through. So we were going very fast, very intensely, and they came through with flying colors. It was interesting. I did most of the videos early in the course, and then they picked up a few of the videos later in the course. And Chase, for example, he did the videos on R and some of the other videos later in the course. I think that using the three tools was kind of an interesting challenge because we went from one visual tool to one that was three that were really a blend of things. I worried about that a bit, but I thought we needed to do it, and the students absorbed it. So they seemed to be very comfortable in different environments, and they just were able to pick it up and act like it was the most natural thing in the world. But the students that were not IS students, the students that were MPA, MBA, MAC students, some of them felt like we were going a bit fast, and they weren't as comfortable as the IS students because that had Mark's class previously, but we knew that was going to happen. And they did great. I mean, even in the presentations they started yesterday, the presentations you saw a few examples, they were doing fine. They weren't as adept at picking up R and things like that as in Azure as the students were, but they learned the foundation skills that we wanted to get them, wanted to get across to them. So basically, these guys they did fantastic work. The course has benefited a lot, and I think also one of the other things that we were trying to do was get the dovetail working with Mark's course, so that as they came out of there, they had a foundation we could build and fill in, and I think that really went fantastic as well. And so all in all, it was really very, very successful.
Also a comment, not a question. I think, like, now that I've seen this all come together, I think there's a lot of wisdom in how this has worked out, because in my class, I picked one tool and stuck with it. That's their first exposure, right? Let's keep it simple in one environment. And I kept going back and forth, well, should I add in this or should I add in that? And we never did. But then in this class, this maps more like what we do right now with our own analysis. You've got 3 different tools. I might have Smart PLS up for this and SPSS up for that, and my own VBA coding that I'm doing for this to clean the data. I think a few different environments, especially with the focus on in this class on model evaluation, which is what I couldn't. Azure isn't the tool to get really deep into model evaluation and comparison. So having this be the second class where they do get exposure to a lot of tools that fill in each other's gaps, but yet bringing it back into, we're still going to be able to plug it back into an Azure machine learning model that can run later on. I think this could work out really well.
I just have a comment too, no question. I don't know that I've ever seen a group that's been as diligent at meeting with their mentor as this group. Like, I'm talking like 3 times a week, I swear. I'd walk by and they would be meeting and working on things. I'd love that. I also just want to make the comment that I really think this will have a really nice impact on students to come. So thanks for doing something impactful to help the department.
I think the learning definitely is not perfect, but it is an impact because we tried. Because we tried a few things that were a little bit questionable, and
we made a lot of progress really fast. And the other thing, if you walked by, you probably noticed there was a lot of laughter. We had a lot of fun. I mean, we worked our heads off, but we really had a lot of fun working together. And I think that was a delight to work with the students. These guys were great. And, they were very diligent. They helped get things done. We were on forced march. 2 modules a week. We were really going fast and hard. And so anyway, I think they went above and beyond what most students probably could be expected to do. These guys were really committed and dedicated and added tons of value, which I appreciate greatly.
We were thrilled with Dr. D. He would come in with ideas, and he would just say, okay, we'll try it. and he gave it a shot, and it was awesome. That happened multiple times throughout the semester.
Here's a question for you. Do you feel now like going back and redoing any of your student evaluations from your other classes after being a teacher?
Yeah, definitely it kind of gives you that different perspective of all that goes into prepping the course and everything, a lot of work that goes into it.
I want specific ideas. We tried to look through feedback, and when people give us specific ideas, those are the ones we tried.
Yep.
So that was the most valuable.
Probably also noticed that sometimes there would be 2 very specific ideas that were exactly the opposite of each other.
Yes.
And they both felt extremely strongly about their specific idea.
Yeah, we definitely noticed that.
All right, any other comments or questions? All right, great job. And that concludes our capstone presentations for the day.